Everyone is awake and important. So, welcome to DC. I'm Charlie Zhang from Samsung Research America. Yesterday, I was reading some news about heat wave here. I was really scared I might be blamed for bringing the Texas heat. Today, by the time I got here, I feel it's really very comfortable. So we need to invite your reporters to Dallas in July. But anyways, very happy to welcome Professor Chang and also our other esteemed guests from Korea to the 6G event here. Traveled all the way to Washington, D.C. for this meeting, and also for all the Next G Alliance members and guest speakers here with us today. I'd like to kick off today's workshop with a few opening thoughts. Next slide, please. Next G Alliance represents a collaborative effort aimed at shaping the future of connectivity, transcending boundaries, and fostering innovation that will redefine the way we interact with everything around us in the future. So Next G Alliance, NGA, was really created to identify and also promote these technologies, especially for North America's needs in the area of next generation wireless technology. We also understand that global collaboration is really critical so that the technology we create can scale to the marketplace and can have global impact. That's why we entered a few of those MOUs with leading 6G alliances around the world. Today, I'm very happy to be here because this is really the first time that we have such a bilateral face-to-face gatherings with Korea 6G Forum. So welcome again. I'm especially happy to welcome our friends from Korea because Korea has long been a really trailblazer in our field of telecommunication, from all the way dates back to 2G, 3G, and also most recently for 5G, very consistently pushing the boundary of what is possible and setting the standards for excellence. So all this time, Korea really demonstrated its unwavering commitment to drive progress and innovation in the telecom industry. So next slide, please. So with this, I would like to quickly go through the agendas for our workshop today and tomorrow. So you can see it's very full packed. We have quite a few really excellent discussions and speeches. So following the opening and introduction, we will discuss 6G government policies from J.D. Griffith of MPIA and Sung-Ho Choi from IITP of Korea. And next, we will hear about 6G standardization from Yongjung Chung and Wanshi Chen. We will also then turn the discussion about Open RAN with presentations from Yong-Hoon Kang and Havish Gurapati. We will conclude today's program with a discussion of spectrum issues in 6G led by Sung-Hong Huang and Andy Thiessen. That's for today. Tomorrow we'll begin with a discussion of 6G verticals from Ki-Dong Lee and Jae-Young Kim. And then we'll discuss migration from 5G to 6G led by Devaki Chandra Modi, and Sung-Min Lee. Afternoon will be filled with a number of technology presentations, including AI, ML design, and enablement in 6G by Ting-Fan Ji, followed by 6G technology from the perspective of the National Research Project by Youngjo Ko, followed by deterministic and reliable networking for 6G radio access network by Doug Casper. Radio technology for new 6G applications by Jae-Hoon Chung. Then extreme MIMO technology for future wireless communication and 6G by Amitabh Ghosh. Emerging wireless technology for 6G cellular systems by Younghan Nam. Driving environmental sustainability priorities in 6G by Bhushan Kochi. And societal and economics needs research priorities by Amir Hormoki. We will finish the workshop with a discussion of future collaboration opportunities. As I said, a very full agenda. I'm looking forward to a very productive conversation. I'm confident that by sharing these ideas, proposals, innovations here, we'll truly unlock the full potential of 6G together. So David, with this, I'm going to turn this floor to you, provide an overview of NextG Alliance.
Thanks, Charlie. Can we go to the first slide, please? So I'm David Young. I'm the Managing Director of the NextG Alliance and Vice President of Technology and Solutions for ADIS. NGA began its journey towards 6G in 2020, and it was established to develop North America's 6G vision. And over the course of that time, we've established and created the key foundational documents, which are available via that QR code. One of the first things that we did was to align on research priorities for NextG wireless and looked at a number of those technologies, and those are all available as well. And we are now moving forward and working towards 6G public-private partnership, looking for opportunities to work with the US government to advance the research and development in this area. Next slide, please. So the NGA approaches the development of 6G from a life cycle perspective that goes from the basic research through development, standardization, and then all the way through to realization in the marketplace. And the roadmap defines that path. We have established our priorities, which are needed to incorporate these innovative applications to meet societal needs and economic goals, and the government actions necessary to advance that. One of the things that the Roadmap Working Group established early on was the audacious goals for the NextG Alliance. These were the priority areas that were critical. Trust, security, and resilience is one of the first. The digital world experience, cost-efficient solutions, distributed cloud and communications technologies, AI native wireless systems, and sustainability. And these 6 audacious goals really established the foundation for all of the work that we've done since the establishment of NGA. Next slide, please. So I want to just give you a quick overview of the structure. The full member group represents all of our members, and those are corporate members, there are government members, there are academic members. So there's a wide range of members who participate in the NextG Alliance. Reporting to them is the steering group, and the steering group really is responsible for managing and overseeing the operation of all of the working groups. And we have 6 working groups: the National Roadmap, 6G Roadmap, the Technology Working Group, the Green G Working Group, Societal and Economic Needs, Spectrum and Applications. We also have a Research Council, which I'll describe in some more detail, and then a Marketing, a Marcom Committee and Policy Committees that coordinate with the steering group and report to the FMG as well. Next slide, please. So these are our leaders, the full member group leadership. We have Igal Abbas from AT&T and Charlie Zhang, who's here with us today. We have the steering group leaders, and 2 of them with us here today, Devaki and Doug. And Brian Daly from AT&T is a co-chair of the lead steering group as well. Next slide. And then here I have all of the working groups with their leadership. And we have all of the working group leaders here with us today who will be giving presentations. So I'm really looking forward to an exciting conversation with the leading thinkers from the NextG Alliance, along with the leading thinkers from the 6G Forum. Next slide, please. This is our research council. We have representatives from some of the leading research institutions in the US who are working on wireless and next generation technologies. And of course, industry representatives who are working on research in this space. And this is led by Dr. Eric Berger from Virginia Tech, and I am the FATIS technical lead. Next slide. And then finally, we have a library of reports that we've created that cover this whole gamut, starting with the 6G roadmap for North America and continuing on and covering pretty much every topic. And again, that QR code will take you to the full library. And so a lot of what we'll discuss is based on the work that we've done and the thinking that's been done over the course of the last 3 years, but also forward-looking as to what are the priorities that need to be addressed and how can we work together. So that's, I think, all for my opening remarks. And now if I could turn it over to you. Thank you.
Good afternoon, ladies and gentlemen. My name is Kyung-Hee Chang at the Ina University, and I'm serving as executive committee chair of the 6G Forum. Nice to meet you. And then I think I remember we had first the online kickoff meeting that was, I think, the last September, right? So it's really nice to see this offline meetings. First, let's congratulate first the offline workshop between the 6G Forum and NGA. And I really like to express my gratitude to all the speakers and participants from the 6G Forum and NGA. And also, I like to appreciate all the to make this event happen, especially to the specialists, including the Madeline. But I still cannot find who is Madeline. Okay, thanks a lot. And then, actually, after the COVID, this is my first visit to the States.
Oh,
wow. And then my last visit was the visit to the 3GPP meeting at the Nevada, what was that? Reno, right? After that, I missed the chance to visit. So this is my first. So since our last online meeting, there has been some modifications on the 6G Forum organization. So the update is we like to focus more on the 6G. So let me briefly, even though I made this 6G Forum introduction during our previous online meetings, let me okay. So whenever I present this, I got a question, what happened to the 5G Forum? But since 10 years of activity of the 5G Forum, so we transformed to the 6G Forum last year at 10th anniversary. So even though our name is the 6G Forum, we are not only doing the 6G, also we are focusing on the 5G, the evolution, including 5G vertical. So by the 10 years effort on these areas, so 5G and 6G, we have published about a little bit more than 60 number of the white papers, but almost all of them is for the 5G and 5G verticals. So I just found out there are the more than 20 number of the volumes published by the NGA for the 6G. So will the pays us. So, and then yeah, so yes, so we are doing the 6G together with the 5G evolution and verticals, and then we have under the umbrella of the General Assembly and then advisory committee, we have the executive committees. So under the executive committee, we have this is updated our organizations. Different from the previous our organization, the main difference comes from the hyperspace committee, expert committee. Actually, the origin of that hyperspace expert committee comes from under the ecosystem committee. You can find out the two working groups, but there were working group whose name was Open Net Working Group. So Open Net Working Group, in addition to the RNL of the Open Net, we added the NTN task. So original name of the hyperspace is the Hyperspace Open Network Expert Committee. So their RNL is the twofold, like NTN and then the Open Net architecture. So they are taking care of those. And then, so now we have the 9 expert committees. Among them, 4 of them, 6G technology, service, spectrum, hyperspace is for the 6G. And then on the 6G technology, we have the several committee chairs at this moment, at this place. And on the 6G technology committee, we have the CONET and the radio access network working groups. On the service, we have the big data and AI working groups. And we also restructured the executive, the members of the big data and AI working groups. We also have the spectrum and hyperspace. And then including ecosystem, and mobility, smart cities, smart manufacturing, public convergence service committee are all for the 5G and 5G verticals. And other than that, we have the strategy and then global teams, 2 teams. Next page, please. Our members are keep increasing, maybe 1 per every month, averagely. So we are not counting the academia members, but we are thinking of we may include the number of academia members. So when we count the member companies or the academias, currently we have the 47 member companies. So including the domestic telcos, vendors, solution providers, and SMEs. Also, we have the government agencies like IITP, and then global companies like the Qualcomm, Ericsson, Nokia. Right? So we have 10 share companies, and the remaining is the member companies. Next page, please. Yeah, this is a forum signature logo. Next page.
You have to modify the Nokia logo.
Yeah. Okay. So another difference is from the last year, we made incorporated bodies, like we build up, established a non-profit corporation under the MSIT, and that means now 6G Forum is under NGMA, which is incorporated, Next Generation Mobile Research Association. That means NGMAs now can make a contract, whoever it is, right? But the 6G Forum, previously 6G Forum cannot do it, but now we can do any kind of contracts, and that's the big difference from the last year. Next page, please. Yeah, this is that. Thanks.
Thank you very much. So now we're going to turn to the 6G R&D government policies and regulator views. And let's start with Sung-Hoon Choi from IITP, please.
Okay. So I'm Sung Choi from IITP, which is kind of government organization handling or R&D budget for Korean researchers or professors and companies. So on behalf of Korean government and Ministry of Science and ICT and MSIT, today I want to share what is Korea's 6G R&D promotion strategy. So this slide was prepared with my colleagues in MSIT. So I need to clearly deliver message from our government. So I'm not sure, we have great agenda for this workshop, right? Today and tomorrow. I'm very interested in tomorrow's sessions. I can learn a lot, 6G technologies. I've been stopped to working for technology development. I'm handling the R&D budget, but I can learn a lot. Tomorrow's discussions, I expect a lot. So I believe this workshop is not just for presenting, but also question and answer, right? Yes. So I hope I can speed up the presentation of these slides very quickly, and I hope to receive some questions. If you have some question about Korean's R&D process or what is our goal, something like that. So I will make a very brief introduction on this. So contents like this, I will show the what is background of these strategies and also more complete our plan to this one by one. So this slide is about first background about our direction. So as everybody knows, the networks have become imperative for economy and societies today. Networks are key infrastructure that accelerates digital transformation by integrating communication technologies such as AI data and cloud into every industry and society. They are the cornerstone of national economic security that determines national economic and communications sovereignty. Additionally, as a national strategic industry, their ripple effects and growth potential are significant. So next background is about evolving landscape. So as digital innovation accelerates, the role and importance of networks are growing even more. The emergence of new services and devices is driving the enhancement of networks. So moreover, as energy issues and security issues persistently arise, there is a need for new technologies to address them. Next background is the evolving landscape. The paradigm of networks, which used to be hardware-centric in the past, rapidly transitioning to cloud and software centric, making preparation urgent. Companies that traditionally manufactured hardware are initiating transitions to become software companies by starting cloud services. Global big tech companies are also entering the mobile communication market through specialized networks, such as private networks. So additionally, the adoption of Open RAN is gaining a momentum. So network transformation is necessary to align with this paradigm shift. So another background. So as the global technical supremacy competition expands and deepens around the networks, securing cutting-edge network technology will determine the outcome of this supremacy competition. With the changing industrial landscape, securing the supply chain has become more crucial than ever. To secure communication sovereignty, countries are making substantial investment in network R&D. A national strategy is needed to address the deepening global competition. So this maybe the last background is the global 6G R&D competition has already begun, starting with proactive investment from the United States. Countries such as China, EU, Japan, and others have already begun large-scale R&D investments for the advance of 6G technologies, including AI native and low power base station. So Korea also began developing 6G technologies in 2021, and will start from this year additional investment in commercialization technology development. So that's what I want to introduce today. And also, this will be the last background slides. So Korea has formulated various policies to secure network leadership over the 8 years. As part of the current administration's national agenda, the goal of achieving 6G has been outlined, and in the October 2022, next generation communication was selected as one of the 12 national strategic technologies. So furthermore, to actively promote the cultivation of next generation networks such as 6G, in February of this year, last year, 2023, K-Network 2030 strategy was announced. That is the core government announcement that was the best for Korean 6G R&D. So this slide shows what is the K-Network 2030 strategy. So K-Network 2030 strategy encapsulates Korea's vision and strategy for comprehensive network innovation through the development of 6G, quantum, and satellite technologies, reinforcement of robust and secure network infrastructure, and the establishment of a robust and competitive industry ecosystem. Korea will pursue 6G R&D in line with the vision of K-Network 2030. So this slide shows what is Korea 6G R&D direction. I can briefly introduce this. So Korea's direction in advancing 6G R&D is structured into 5 aspects. Firstly, it aims to innovate wireless communication through the development of upper mid-band technology and coverage expansion technologies. It also seeks to adapt to a network changes centered around the software, such as Open RAN, Cloud Native, and AI Native. And communication networks will play a role beyond the traditional communication by utilizing computing and communication combination, and also sensing and communication combination. Also, efforts will be made for energy saving technologies. So additionally, there are plans to strengthen the supply chain through the development of communication components and components technologies to secure communication. To achieve this 5-year 6G industrial technology development project has launched from this year. Actually, the project now, the key leaders for each project, 27 project leaders were selected, but now we are giving kind of contract going. So this project will start hopefully tomorrow. So 5-year project will start hopefully tomorrow.
Yes.
Maybe we'll kind of contract this on an individual project leaders. So this slide shows the brief of the Korea 6G R&D program. I'm very proud of to have this project. I spent almost 3 years to secure the money and started the project. So start project this year from tomorrow. So let me briefly introduce the slides. So 6G industrial technology development project will promote technology development and standardization in 5 major sectors, consisting of 13 strategic technologies. 6G wireless communication is first. Second one is mobile core network and wired networks and system and standardization. A total investment of around $327 million. In Korea, for 140 billion Korean won, which is around $327 billion. It's planned over 5 years, and pre-6G technology demonstrations are scheduled for 2026 to expedite the commercialization of 6G. There's a brief of this project. Or if I go to the one by one sectors, in the first the 6G wireless sector, plans are on the way to develop communication technologies utilizing the upper mid-band to overcome the capacity limits of the mid-band used in existing 5G, as well as the coverage limits of the millimeter wave bands. So this development aims to achieve a high capacity and also extensive coverage. The mobile core network sector, efforts are being made to develop cloud native based core network technology to provide high performance, high availability, and highly flexible services. So additionally, development is underway for AI native mobile networking technology, not only for mobile core network, but also RAN side, to ensure autonomous control and service quality assurance. So this one is the 6G wired network sector. So efforts are on the way to develop ultra high speed and high capacity optical transmission systems and component technologies from the 6G front haul to delivery network segment. enabling ultra realistic and high precision services. And this sector is a system is a little bit different from what we have done in R&D in Korea, but we added a system sector because we believe this sector is very important to enabling new services in the 6G area. So development is focused on the ensuring diverse and complex quality of service required by various 6G converged services such as XR, Metaverse, UAM, and 3G holograms, etc. This includes the development of wireless and wired resource orchestration technology to ensure end service performance, and the AI native application services support technology. And the last sector, 6G standardization. There are plans to develop core 6G standard technologies, support standard activities in academy and industry, and cultivate standardization efforts on dedicated research support system centered around the standard will be operated. So actually in Korea we have very good companies, Samsung and LG Electronics, which are very active in standard, but Korean government also support professors and R&D centers and other companies to actually joining standard using this government project. Okay, this slides for pre-6G demonstration. So we'd like to share Korea's vision of 6G technology through the pre-6G technology demonstration in 2026. The pre-6G technology demonstration aims to showcase Korea's efforts in 6G thus far and share its vision of 6G with the world, hoping to create a platform for collaboration with everyone. Okay, this is expected effects. So through the 6G industry or technology development project, Korea aims to formally establish its position as a network powerhouse by securing 6G technology and hopes to strengthen its competitiveness in standards as well. Furthermore, Korea anticipates building a stable supply chain and fostering organic cooperation among enterprises and creating opportunity for Korean large, medium, and small businesses to grow together. Okay, thank you for your listening. Thank you. I think I have some few minutes.
Yes, we have time for questions. 15 minutes.
I have a quick question. Are you working on spectrum sharing
Spectrum sharing.
Thank you for that leading question.
I think that will be the part of this project. So we are targeting the. As I said, we have several projects. This is the strategic technology. Under this topic, there are a few projects. So in total 27, but among these, we have around maybe 7 or 8 projects. Among them, to use the upper mid band, definitely kind of spectrum sharing technology should be developed. So we did not identify that topic should be studied, but we just provide the guidance or top budget and key player in this project will develop this technology.
Thank you.
Anyway, upper mid band.
So you are excited about upper mid band?
Yeah, our government strategically dedicated provide ethical research project for this, because we spent some few projects before I have slide. We had the 60 core technology R&D program around 5 years from 21. At the time, we Korean government selected sub-terahertz as a 6G spectrum, but recently we changed our strategy. So that's why we will focus on the upper mid band.
So upper mid band, which band? 7 to 8.5 or?
It's open still. So we rely on the ITU-R discussion, but the candidate spectrum was
Yeah, that
But
will be
it's not
discussed,
ITU.
but you are more focused on 7 to 8.5 or 13 to 14.
7 and 13 both, I think.
Thanks.
We will have a system-wise project. We will cover particular spectrum, and we will develop the base station components, RF content, module or components that rely on the spectrum decision. So spectrum decision will be rely on program discussion standard.
Yeah, I guess related to Amitaba's question, right? So not only the bands are important, global harmonization will drive the ecosystem, but also so far all the Gs are either FDD or TDD. And finally, in 3GPP, we're talking about full duplex. Right? It's not neither FDD or TDD. It's sort of unpaired spectrum FDD, put it that way. So from Korean perspective, is regulator, KCC, are they also considering allocate spectrum to accommodate these new duplexing schemes? Because it's supposed to give us better coverage. And
could you repeat the question for the folks who are
Alright, then.
listening online?
I think his question is about
full duplex,
duplexing, right?
sub and full
FDD
duplex.
or TDD or full duplexing.
As part of your eMIMO technology,
Right.
are you also looking
So
into
we
different duplexing?
assume not full duplexing technology for developing this eMIMO system, but we have separate project to the research on the duplexing technology. So the government did not decide anything about spectrum allocation, which way we will go, but I believe that it also depends on the progress in the standard. So our government also expecting good result from the discussion next year, 60 workshop in 35th. I believe multiple companies, multiple research centers, research result will come together in next year, in March, in Korea, the workshop. Mansi will share, right? So hopefully that discussion provides some directions. Okay. Spectrum allocation also need to process spectrum.
It's already expected to be defined in release 19 in 5G advanced. So in some sense, the technology is already there, but it does need regulators to enable it, right? It does need OEMs, infra vendors to provide the technical implementation. So we're still one step away from the actual realization of this full duplex. It would be good to.
The other guys want to answer that.
Hi, my name is Jung Jung from the Electronics. I already checked with some Korean regulation aspects in the spectrum. At the unpaired spectrum allocation case, already in Korea, regulation is support any kind of advanced full duplex can be supported in the unpaired spectrum. Or let's say the TV. When it comes to the FDD, we still have some investigation, but our spectrum committee's basic view is if there is any new technology is introduced in the industry field, and it could be some supportive operation in this regulation making job, even in the case of FDD, is can be also taken into account in the future. Sometimes. Yeah.
Thank you.
Actually, the discussion is about whether the government decides whether to allocate spectrum for flex or other FPD or
Yeah.
3D.
That's why I can say such a right things is our company is already checked with the government view.
But I'm the part of the spectrum policy kind of, members. So actually, those people are not the technology experts on this area. So government policy also depends on the technology development, whether it's feasible in the market or not, or product will be ready for that or not. So government cannot just decide this spectrum should be for the flex or other technologies. So they will wait until all the technology development discussions.
Do we have any more questions? Yes.
So you mentioned, I think, demonstrations in 2026. I was curious whether those are based on a certain vertical or applications or technology focus. I mean, what is the kind of the focus for those demonstrations?
This demonstration, our design for this was, as I said, we have around 27 projects. Those projects include all the area, not only your question about wireless area, but our project including wireline or front haul or mobile or network and all the system ONM. So those all technology we want to put together into one space, and we want to show it whether it works or not after we develop all the technologies, aiming for 6G commercialization. It's too early because standard is not ready yet, so that's why we set pre-6G technology. But the demonstration feasibility shows help standard progress. That's why we wanted to have kind of demonstration.
Okay. So it's pretty broad.
So the project specific to pre-6G demonstration, they will be started from the next year. So even though we just define the scope, the more details will be decided from next year.
So we will invite not only members of project in Taiwan, but also outside of other countries.
So for 5G, you showcased in the Winter Olympics, right? So any
It will
such
be
event?
different. We are planning to have that kind of showcase 2028 end of this or project. But this is middle of the project. It's not feasible to show some
No,
applications or services.
so you showed in Korea 6G Winter Olympics. So similarly, we have 2028 LA Olympics.
Right. Hopefully, some of the Korean companies will join the American event.
Are there other questions? I have one question. You mentioned support for 6G standardization. Can you say a little bit more about how the government provides that support? Is it through funding or are there other mechanisms?
Well, we just provide funding. So few teams, we have three projects for this. One is for RAN 1.4 team and RAN 2.3 team and SA1 and SA2 team. So we will provide R&D budget for supporting all the standard expertise, participant and turbo. So as Samsung and LG Electronics has a standard team in the company, we will have professors or R&D centers has dedicated resource for standardization. Thank you. Actually, it is the first project like this. Usually we have a big development project and some participants of development project to participant standard meeting. But that is not really efficient to have good output. That's why we dedicate project only focus on the standard.
Thank you.
A question. For the standard participation, what is the objective ultimately?
smoothly, as exactly same as the Samsung standard. Develop new technology and contribute to standard, and including the APN, IPR, and so helping all the ecosystem for standard.
So on that, are you seeing that there's more of a focus on that for 6G compared to 5G? Like is the support for standards development and standards activity increasing? So is the support increasing for 6G relative to 5G when it comes to the focus on standardization? From the
In the government point of view?
Yeah.
Yeah, before Korean government didn't have this kind of project, dedicated standard project. Korean government has some few projects for developing 5G technology. So the members who developing those technology, some of the participants of the project can go to the standard and deliver their output to the standard. Because there is not really sufficient. It is not that we couldn't have a good result from we have dedicated resource to the standard. And also, actually, in 5G, we have the 5G technology development project, but at the time, we focused too much on the applications, what we can deliver as a user experience, not focus on real technology development. So our design for this new project is focus on more technology development, component level or product level, and technology output, not only wireless, but also wired and mobile core and all the O&M for service management aspect. So I believe the design of this program is very good.
Great. Well, thank you very much.
Thank you.
All right, and next we'll be joined by JD Griffith from the U.S. government.
Thank you, David. Good afternoon, everyone. It's a pleasure to be with you all today. My name is JD Griffith. I am the Chief Technologist for the Public Wireless Supply Chain Innovation Fund inside the National Telecommunications and Information Administration. A lot of words, it's a mouthful, I apologize. So for those who may not be familiar, NTIA is the Principal Advisor on Telecom and Information Policy to the President and the White House. Our role is to drive a lot of some of the ministerial functions within the U.S. government around telecom policy and information policy as well, hence telecommunications information. Right? With that, we've touched a lot on 6G through our role as the manager and I'd say quasi-regulator of the federal government's use of spectrum, and working in close collaboration with our colleagues at the FCC who regulate spectrum for state and local government and the commercial sector on what 6G can look like moving forward, as well as our domestic and national policy offices working with our broadband programs and working on the innovation fund. So a lot of people over time wonder, why is the USG getting more involved in telecom space? We have a relatively light touch in 5G. We've become a lot strong embracer of open radio access networks, and we're looking hard at how we can kind of contribute into the 6G research and development and the development of 6G technology. So there's kind of two key areas we're looking at here is security of our networks. So this is creating alternatives to untrusted suppliers, especially those coming out of the PRC, looking into how to improve network visibility so network operators can have better understanding what's going on inside their networks, and also how we can secure supply chains better, because we've learned through the COVID pandemic that it takes a fine grain of sand to screw up the watch that is the telecom supply chain. So we really do want to look at ensuring that, because of how much this wireless infrastructure has become critical technology for both our national security and the operation of our society, but also for economy. But we're also looking from a competition aspect as well. We want to make sure we lower barriers to entry through enabling interoperable networks so we can have more competition in the space, more innovation through innovative technologies that we can roll out to consumers, roll out to industry verticals to improve their operations. And again, make sure the supply chains are more resilient in addition to secure, so that not only do you ensure that the product you're getting is, what it's supposed to be, there isn't any counterfeit products or any tampering, but also ensuring that supply chain as well. There we go. There's the button sequence I'm looking for. So in 2023 and earlier in 2024, especially around the World Congress, the U.S. government released some principles on 6G networks about security, openness, and resiliency. And these are the 6 key principles that came out of there. So for the notes, we want the trusted technology to be protective of national security. We know how critical this technology is becoming for our telecommunications networks. We want to ensure that it is secure and that we can protect our national security by ensuring free flow of information within the United States and to our allies. We want this to be secure and resilient, protective of privacy. So this includes, how do we take a systematic approach to cybersecurity in 6G networks, not just something that kind of bolts on the end as an optional feature. How do we protect the privacy of individuals? Individual and consumer privacy has become a very hot topic in the United States. And so we're very interested in how we can leverage 6G technology to ensure that, consumers have control of their own data and it's protected by 6G networks. And then generally just the security of our communications. How do we ensure that we don't have any risk of eavesdropping or man-in-the-middle attacks as, whether it be a private citizen or the US military or what have you communicates across 6G networks. We want a globally led and inclusive standard setting paradigm. This really means that we want open and transparent, impartial and consensus-based standards. We have a pretty good track record of that with 5G. We did a lot of work through 3GP, but I really want to think the key part here is global as well. And I'm really glad to have the delegation here from Korea, because if we don't have that's a consistent global standard for how this technology should work, it's going to be trouble to try to maximize the impact of the global marketplace. Dare I bring up 5GI and all the drama that caused. So we really want to ensure that kind of we're all together on how 6G will end up working together moving forward. Want to cooperate on enabling open and interoperable innovation. So a lot of this is fulfilling a lot of our work that we've done with 5G on Open RAN and ensuring interoperability with access networks, leveraging a lot of the interoperability that is already present in many of the core networks we've seen in the 4G and 5G, but also looking at how we can further that, building towards that seamless interoperability between suppliers across the entire network, and how we can also benefit from joint research, development, and testing between the United States and our partner countries. We also find it really important the affordability, sustainability, and global connectivity. It's really easy to just focus just on the United States or just on developed countries in the US and Europe and Asia, but really looking at how this kind of builds a global economic environment, especially as both Africa, the Middle East, South America, Southeast Asia becomes more ingrained into the global marketplace. How do we look at how energy efficiency can make sure we maximize the use of our resources, not just on the network, but also in the energy we put into the network. How do we bridge that digital divide? The United States has invested over $60 billion in the last few years to close digital divide, primarily looking at wireline networks. But as a lot of people move to, some houses just use cell phones for their connectivity, how to look at a lot of countries throughout the world that do not have the resources or infrastructure to deploy wireline networks and then rely heavily on wireless. How do we work together to ensure that we can bridge the digital divide both in our own countries and across the world? And how do we reduce the environmental impact of other industries? So a big topic and personal passion of mine is how 5G and 6G can support business to business use cases. How can we, accelerate industrial automation, precision agriculture, maximize the effectiveness of resources in other industries, and how can 6G help other industries reduce their environmental impact, improve productivity, and improve output. And then finally, everyone's favorite topic, Andy, the spectrum and manufacturing. So we want to ensure that we have secure, resilient supply chains. We want to have a globally competitive market, ensuring that the manufacturing is in place so we're not necessarily too concentrated in any one part of the world. All the manufacturing for 6G shouldn't just be in the US, it shouldn't just be in Asia, it shouldn't just be in Europe. We ensure that we have a globally cohesive market for the entire supply chain. And then efficient and shared use of spectrum. Spectrum's a hot commodity. Everyone wants more, and there's only so much. And the people that have the spectrum don't really want to give it up. And so how can we maximize the efficacy of the spectrum we do have? How can we efficiently and effectively share spectrum with incumbent systems like DoD radar and things like that? I think that's going to become especially important as the U.S. and Korea on the government side have been longstanding partners, both economically, politically, and militarily. But especially since we have that tight defense cooperation, ensuring that many of our systems are the same or use similar technologies. How do we ensure that that cooperates with spectrum desires for civilian use of 6G systems? So I think everything on here, except maybe the first line, I think that might have been included. Actually, all 6 were included according to my notes on this principles for 6G that's released at Mobile World Congress last year. And we had a number of governments from throughout the world that endorsed, including the Republic of Korea. So we're really excited to be working closely with our Korean counterparts on advancing these topics. So across the US government, we have a number of agencies involved at this stage in 6G development. So we have NTIA, of course, the Federal Communications Commission. We also have the National Security Agency and our State Department working together closely on how do we ensure that secure, resilient 6G can connect the world. But also when we start looking into getting on the ground with research and development of technologies, NTIA has been interested in 6G R&D through our Public Wireless Supply Chain Innovation Fund. The National Institute of Standards and Technology, or NIST, and other partner agencies of commerce has been doing a lot of internal research on 6G. And we'll talk about one of their recent reports they've done with the National Science Foundation. And then the US Department of Defense has been very interested in 6G, especially open networks as the standards start to develop and progress. So this is a very much non-exhaustive work to date of how the US government's kind of played specifically in the R&D space. So in 2023, the National Science Foundation hosted a 6G workshop, invited a number of international partners. Can't remember for sure if Korea was on that list or not because I wasn't that plugged into the planning. But to really kind of discuss how do we ensure that 6G is open and resilient by design from the start. Since April last year, what standards may look like for 6G was just a hallway conversation yet. We hadn't seen any of the workshops in 3GPP or other SDOs kick off yet. In December 23, NIST and the NSF released a report on next generation communications R&D gaps, specifically covering what are some of the trends in the space and some of the gaps in different research areas such as hardware, spectrum use, including sharing, joint communication and sensing, AI and ML and 6G networks, data availability and use, and including privacy, network architecture overall for 6G non-terrestrial networks, and how do we make next generation networks sustainable. So it covered a wide breadth of areas on where the, at least as of December last year, saw some gaps in research and development. Earlier this year, as part of the US-EU Trade and Technology Council, adjacent to that, the National Science Foundation signed an agreement on 6G technology with DG Connect. I can't remember what Connect stands for, but it's the connectivity directorate within the European Commission. So we work quite a bit on them on both Open RAN and 6G discussions. amongst many of our international partners. That's just as an example agreement. The Department of Defense with the Office of the Undersecretary of Defense for Research and Engineering, another really long name, has started kicking off work around for their Beyond 5G initiative on open centralized unit and distributed unit software. So really looking at how to open source the compute side of the radio access network as we start building out 6G networks. So we have kind of virtualization by design from the start. And leveraging a lot of the lessons learned from the IT industry that we've seen, the hyperscalers and large industries around the world kind of build off this base of open source technology to enable them to leverage economies of scale to build their proprietary products. NSF, the Breaking Low Latency Barrier for Verticals and Next-G Wireless Networks, also known as Breaking Low. This is really, trying to foster cooperation between academia and industry on cooperating in one area that we haven't focused on a ton, I'd say, outside of standards for 5G, which is, ultra low latency and what verticals need to be able to do that. So they're really trying to kind of develop those use cases collaboratively between academia and industry so that we can have that use case first in mind as we start rolling out 6G standards. We have the NSF Next to Area Wireless and Spectrum. This is a really interesting one. This isn't explicitly 6G, but I think it's going to have a major impact on 6G. This one's looking about not only what some of the new use cases on how we can use spectrum technology across all fields, including communications, but also how can we use it efficiently and how can we share that spectrum efficiently. And then finally, so the Public Wireless Supply Chain Innovation Fund, the program that I work on, we are releasing our second notice of funding opportunity soon. Stay tuned next week. You didn't hear that from me. I hope no one's recording this. We'll have Katie edit out that part. But yeah, barring any, the U.S. government doing what the government does, very soon we should see, have some details to share on that. But it's really just this sampling goes to show just how across the board the U.S. government's been looking at 6G and the work that we can do to help, move forward industry, work collaboratively across our partners and ensure that, it is a competitive landscape that every part of the world can participate in. And I'm happy to answer any questions for as long as David will allow me.
Great, thank you, JD. Do we have any questions?
Go ahead.
I have a very small question.
Mhm.
Just this is just for the clarification. So there is is there the basic difference between NTA and NSF? Or we understand NSF usually support the research fund research to the academia.
Yeah.
And so
Yeah, so NTIA kind of entering into this, technology innovation area is relatively new. So the Innovation Fund is a $1.5 billion program authorized through one of the National Defense Authorization Acts, but was funded through CHIPS and Science as part of a broader, technology advancement industrial policy initiative. So part of what differs our work from NSF is that this is kind of a one-time program. We get $1.5 billion and we have 10 years. What happens after that is unclear at this point. Maybe Congress will give us more. Maybe it's a one and done to shift into the market to go in the correct direction. Only time will tell. But we have been working closely with NSF. Are you familiar with the technology readiness level system of 1 through 9? Yeah. So NSF is typically, you see a lot of the TRL 1 through 3. We're targeting trying to, depending on the topic, a lot more of TRL 3 through 7.
Oh.
So trying to bridge some of that value to help bring, products to market, figure out how we can really take new innovative ideas and de-risk it so it's a lot easier for industry to adopt, especially as it relates to open interoperable networks. Yes.
So the similar question in the previous slide, you said you mentioned about the last NTIA Public Wireless Supply Chain Innovation Fund.
Yeah.
It's 1.5 billion for 10 years. is a little bit different from NSF funded project that is usually dedicated to the academy. But
Yeah, so
NCIAA is open not only for academic but also companies in America.
Yeah. So we've kind of, depending on the topic, and we're trying to take a strategic approach in how we roll out our funding and support research. So I'll kind of use this example. We have $1.5 billion. Congress just said, make telecom, 5G and beyond open and interoperable and virtualized and secure. And here's the 7 congressional bullet points on what you should do. Go forth and do good things. So $1.5 billion is a lot. I'm sure the colleagues in the room from Samsung are laughing at me at my measly, tiny $1.5 billion R&D budget. So what we're really trying to do is, while we kind of have a broad mandate, we're trying to target where can we strategically place our funding and nudge industry in the correct direction. So a lot of that does include, we do not have to work with just academia. If you look at our first notice of funding opportunity, which is more around testing and evaluation, it was open up to everyone. We had awardees that did include a lot of universities for doing research and development, but also a number of small companies and startups, as well as some large companies that work to develop our testing evaluation laboratories. Going to the second NOFO, I will say it's different. Stay tuned for more information, but there is a role in the next NOFO for academia and companies of all sizes, depending on the topic area.
So it is for small size companies, then no for two.
Companies of all size,
All size.
yeah,
All size.
have a role in the next NOFO, and academia.
So you said next week, something like that before. So kind of fund preparation is almost ready, but is it also ready for, as you said, which topic or which area focus on those funding? Yeah,
so we've thought of, and unfortunately we can't go into a ton of what our internal debate is because it is a competitive program. We don't want to give one, outfit a leg up over another. But we do kind of pre-select broad, what we call specific research focus areas ahead of time, because in the statute that created the Innovation Fund program, we are, it's a $50 million maximum award per entity per specific research focus area. So that has never been defined before in US law, so we made up our own definition. And so we kind of define, some research topic areas as those, specific focus areas, and then assign funding and criteria, then we kind of bundle multiple RFPs into a single RFP, if that makes sense. So when the NOFO rolls out, it'll say which, focus areas we're trying to target, what the eligibility criteria is for each of those focus areas, how to apply, all that stuff. So at that point, those solicitation goes out. We'll kind of reveal what everyone's been asking about of what's coming next and how do I apply.
Okay. So last question from my side.
Mm-hmm.
About kind of overseas collaboration project also included in the project?
So in this next one, stay tuned. It's not no, but there is some criteria around what international collaboration can look like in this next round of funding. That said, we do collaborate quite a bit with a number of our partners that are interested in the open RAN space. And we're always looking to have more conversations on how we can leverage either non-financially and like coordinate and deconflict and connect our funding recipients together and see how we can collaborate across borders. But we have depending on priorities at the time, we have looked into how can we do some joint funding mechanisms, and it sounds great on paper. In practice, it is a very complicated approach. So while we we keep bringing that up every 6 months or so and reevaluate to see whether we're at a point where it's feasible to do joint funding. So far, we have not hit that time yet, but I do think we are definitely interested in how we can work together with the Korean government on what y'all have been funding, how we can collaborate in ensuring that our industries work together to support the broader economy.
with the standardization starting, say, next 1 or 2 years, this, if you, all this funding has to be done expeditiously. So when do you think will the funds be available once you decide?
Well, look who, the $1.5 billion question. So there's definitely, we have definitely received strong signals from both in and out of government that funding go fast.
Oh.
Roll it out as soon as we can. I would say the other side of that coin is when it's funny when the government, within government, whether it be Congress or other parts of the executive branch, say go fast, yet we also want you to comply with all these regulations to go fast. So it's trying to balance doing our due diligence along with, getting funding out in a timely manner. So we are trying to work, as I say, and I know in the international crowd, this idiom may not land well, but we're pedaling the Flintstone car as fast as we can. So we are trying to roll out as soon as possible, and understanding that some of the 6G, we are starting standardization soon, but 6G standardization is not ending anytime soon. That's an important thing to remember. And even 5G rollouts are still starting in some parts of the world. So you see both a fair amount of runway left in 5G, and even with some of our R&D efforts, we understand that in the grand scheme of things, maybe a little bit behind. Overall, we still think we're in a good time frame to truly push some of the innovations that we can develop in the United States and around the world into standards.
And there's a question for Charlie.
Yes, thank you. So on the topic of a spectrum, right? So as you know, sub-premium band or FR3 is of a lot of interest for 6G research. So on the industry side, I think one of the key challenges is uncertainty of which band, which particular subband to focus on. As Soho, when he was presenting also, he was talking about having to work on both 7 to 8 and 13 together. That's kind of what we are doing across the industry because of the lack of visibility. So I understand a lot of discussion is still going on. Do you have some visibility on the timeline when this will be resolved?
No. Thankfully, I do not work for our Office of Spectrum Management, so I don't have too much insight into the fun debates that go on there. I would say, like we do, the U.S. government does understand the need to, move fast on spectrum, and unfortunately, there's a lot of complicating factors, both as identifying the spectrum, but it's also dealing with things like the FCC currently does not have. And someone correct if I'm wrong, following Congress still does not have their auction authority. That's true. So even if we made spectrum available, there's no way, other than like traditional licensing, which I think everyone agrees is not the right approach. There is no way at the moment for us meaning the FCC, to get that spectrum out to industry. I would say if you haven't taken a look at what we put in the National Spectrum Strategy, we do identify a few key bands and use cases that are going to be investigated through that. I know the implementation plan for the spectrum strategy is, if it hasn't been released yet,
It's out.
It's out. Yeah. The implementation plan's out. I'm sure I'll go into more detail, but I have not read it yet. On exactly how the U.S. government's going to tackle investigating each of the bands identified in the strategy. A lot of it is that, FR3, 7 to 24, especially 7 to 8.125, I believe.
Yeah.
I think that's going to be a key frequency range. That's probably going to be that, and the somewhere around the 12, 13 gigahertz are going to be the two main ones, just because there's already been some work done at the FCC for that 12 and 13 gigahertz work, but also 7 to 8.125 is a very hot candidate band at the moment. So I would say that's probably where we're going to see it happening in the near term, but keep an eye out for further developments on the National Spectrum Strategy, and then Andy's your man on all things spectrum within NGA.
I think there was a question here. Next.
Yeah, just for my clarification to go back to the 6G baseline. In there, in the first bullet, there might be some wording of a trust technology, and I'm actually working as some private sector R&D engineer, so once 3GPP captured some technology into some specification, and so most of our standard engineers regards some all kinds of captured technology as some trust in any case. So what is the purpose of such a emphasizing some such wording of a trusted technology? And do you have so many bad type of example in this untrusted technology?
So I can think of one company that starts with an H and another company that starts with a Z that in certain neighborhoods that we would classify as untrusted technology. So I don't think, I'm sure there's probably some cybersecurity engineer that's about to wake up and scream my name when I say this, but as far from the standards perspective, I think part of what we like about 3GPP and other open and transparent processes is there is no, when the work's finally done and complete and the standards released, there is no, arbitrary smoke-filled room where some of those decisions were made. We have confidence based off of the working procedures of 3GPP that, industry's due diligence went into this, and I'm going to say in theory, the technically best solution is what came out. And so that's kind of like we viewed the standards process generally as long as it's kind of open and transparent and inclusive, where it's not so much, any individual member of 3GPP operates on a relatively equal playing field as the others. So we view that as a trust success, even though some companies we consider untrusted are participating in that process. It's still a predominantly democratic process and how those standards select. That said, most of our trust issues come into what happens post-standardization, when the equipment's actually developed and who's doing the developing, are they under any sort of extrajudicial control of any government where, I can require you to give me data of all your customers. Also, you're legally required to not tell your customers. And I can do this at any point without any judicial review, that sort of thing. That's where a lot of our trust and security issues come into, is around, okay, how was this built? How does the supply chain risk management look also as well? Do you have a well-vetted, supply chain from I get, the chip is minted at the fab to it's on a circuit board to it goes into a radio to it's finally on the tower, to make sure there's no counterfeiting or any other, ensuring you're getting legitimate products the entire step of the way, all the way to the customer. So I would say from a standards perspective, while important, and we want to make sure that 3GPP and other SDOs maintain a transparent and open, approach to how they develop their specs, we see a lot of the trust issues happening in other parts of the development process.
And I think there's time for one more question.
Yeah, JD, it's music to my ears when you said 7 gigahertz is your near-term priority.
Don't quote me on that though.
Okay, so that's that's really great, because from the industry we can't wait for you guys to give us some more information on 7 gigahertz. Our current understanding is DoD is more focused on 3 gigahertz, and then they want to move on to 7 gigahertz, which is a little bit I think from our perspective we should look at 7 gigahertz as early as we can. So maybe can you give us a little bit insight how NTIA and DoD are coordinate on these things? How you guys?
That's out of my wheelhouse. So
Maybe
I can say that there is coordination. What goes on inside those meetings, I think, depends on, and how well those meetings go depends on who you ask. Because it is tricky trying to balance the economic needs of the United States and the global market with, the national defense needs. And like any human-ran institution, it does become territorial at some point, not necessarily the best decision for either institution. So unfortunately, I don't have much insights. I would say, thankfully, I don't have much insights on what goes on in those discussions. So I would say stay tuned, and then we can certainly work. I'm going to actually lean on Andy. Andy knows everyone in the Office of Spectrum Management, at least the important ones. So, and in DoD, so talk to him.
All right, and Devaki, I think you can get that.
also be at the coffee break if there's more questions.
Yeah.
Thank you. I just have two questions on the public wireless supply chain innovation fund regarding the timeline. I guess you had mentioned, okay, we still have runway towards for 5G deployment, and we still will have 6G standards ongoing for a while, right? I just want to stress the point that, you know, even though we will have multiple releases of 6G standards, the first release of the standards has the largest impact in implementation and the deployment, right? So if we really want to make an impact, I think the earlier the better. I just wanted to reinforce the point of the first release of the standards. And number two question I had is, do you also foresee some kind of a public-private partnership here, like collaboration between the academia and the industry for such research projects? That's available via this funding, or how do you see?
So in terms of what I can talk about before the document comes out, I'd say we're definitely interested in seeing, we are interested in seeing public-private partnerships. We do think both industry and academia have something to bring to the table. That said, we want to ensure that, these partnerships are meaningful. It isn't, I'm a researcher at university of whatever, and then I get all my buddies and standards to sign on as supporters, but they're not really contributing. They just think I have a good idea. So we want to ensure that any of the partnerships that we see coming out of our funding does lead to meaningful relationships. And I do think there is I talked about which levels of funding we're trying to target and how we differ from NSF. Moving a technology from TRL3 or TRL5 up to TRL7 ready for getting close to commercially ready, that takes a lot of work, both with the researchers that develop the technology and industry to actually make that happen, and identifying what is the commercial use case for this. How do we no one likes to talk about the companies survive by making money, and how do we ensure that this is a desired technology that there is a market for that can be economically feasible to support. And so you'll see more of an emphasis on that as well. How do we can transition this into the commercial space? Obviously, when you're at TRL3, you may not have have the following companies signed up to buy this, but we need to see that there is a plan. It can't just turn into a research paper that exists in IEEE Explore, and that's the only place it exists.
And how did you get the last question?
I'm picking up a little bit on what Ping Time was saying. So the whole spectrum situation, coming back to spectrum, is quite complex, right? I mean, there's all the different bands would have, there are technological differences, deployment differences, and then also, license sharing, unlicensed, the whole spectrum, right? And at least from an industry perspective, it seems that the answer is basically all of the above. We need to, not just pick one or the other. And it's really important, it seems, to look at the whole thing holistically and make sure that we have a strategy where we get enough in all of these bands of all types. And so is all of that being managed out of the spectrum strategy or the Office of Spectrum?
Oh, don't look at
management. So my question is, who is the SAR of all of this? Because you have all of these moving parts, but
if you ask NTIA, FCC, DoD, and the White House, you'll get 4 different questions, or you get 4 different answers on who's really in charge. So I think a lot of it is ultimately a close collaboration between NTIA and the FCC, where NTIA's role is, kind of dual-hatted. Obviously we are the curator of how the federal government uses spectrum, including the Department of Defense, but the FCC, rolls out spectrum for the commercial sector, but NDA also, since we're under the Department of Commerce, we have also a broad responsibility to support, U.S. economic competitiveness and innovation. So a lot of it kind of comes down to, it is, as much as each agency would like a single czar name, the problem is each agency wants them to be named the czar of ruler of all things. So I think a lot of it's still going to come down to ensure we have collaboration, because there's important equities in each. And it's really difficult to say, oh, this agency should be in charge of it all. That's some of the contention you saw in the past, 5 or so years on, C-band. Came a lot down to, well, the FCC thinks commercial is more important than defense, and defense thought defense is more important than commercial. And so that's what led to a lot of the political battles around spectrum. So we're really trying to, get everyone together, understand what the real cost of either, standing up spectrum sharing or relocating systems. And I think a lot of it also kind of comes down to, as much as certain parts of our industry hate the word spectrum sharing, that's going to be an important part of the discussion, because we took care of the low-hanging fruit of relocating systems. We're in the part where it gets a lot more difficult, costly, and especially when, I'm put this bluntly, when operators are on stage at World Congress and other fora saying, we're not making any money off of this. Also, we want you to spend billions of dollars relocating this equipment so we can spend billions of dollars that we may or may not have on spectrum, isn't really the best narrative. So that said, I'm not an OSM. I'm not worked for the FCC either, but I think, from my, outsider looking in perspective, this is some of the calculus that's going on in determining how to open up what bands when, what does relocation look like, what does sharing look like, and how to make all this kind of work together.
And I'll just throw in that the National Spectrum Strategy Implementation Plan is very detailed. It has detailed plans for each one of the bands that are going to be studied and timelines. So and how the process is going to work. So definitely worth reading. JD, thank you very much. Really appreciate your time.
Thank you all very much.
All right, and with that, we're going to go into a half-hour break. We have coffee and refreshments outside. So.
Thank you for introducing me. Yeah, good afternoon, everyone. My name is Yong-Chun Chung. I'm working for TTA, and then I'm in charge of radio and broadcasting standardization in TTA. And thank you. Firstly, I'm very pleased to participate in this workshop. And thank you very much for giving a chance to present today here, especially in Washington, D.C., which I had visited 20 years ago. And wow. I came back, and it's a wonderful city. Thank you very much. Recently, actually, TTA has been discussing with artists for some further expanding our cooperation. And now is very good chance to introduce our 60 activities in TTA. Next slide, please. Maybe I will. So today I will present first. I will introduce ICT standardization system of Korea. Then nextly, I will introduce the TTA activities on 5G and 6G, focusing on our some work programs. This chart shows our some ICT standardization system in Korea. For in this ICT area, actually TTA standards is quite influential in Korea for covering ICT areas. So among our TTA standards it is common for them to be established in national standards. And also TTA, normally developing TTA standards in domestic level, but further some international level, facilitating international level, we operating some national committees, for example, Korea ITU committee, and as well as APT and ISO IEC DHTC 1 area as well. And then also we are operating some program, maintaining our standardization experts. We actually selection and support them for their contribution to international level SDOs. And also we are operating ICT standardization strategy forum for their developing their forum standards, and then they are promoting domestic level. And this kind of study functions is quite unique in Korea. And also we have the collaboration with overseas SDOs. Yeah, this is kind of some ICT areas of our standardization activities. And at the national level, we had some two ministries. One is Ministry of Science and ICT. It is responsible for some ICT standardization. And the other party is MOTIE, which is the Ministry of Trade and Industry and Energy. They cover all industrial standards at the national level. And that's a slide that shows our TTA expertise for the global standardization. In this area, normally the standard is focused on interoperability and safety and security, but in this digital transformation era, we'll focus on trustworthiness as well, and inclusiveness and sustainability as well. So with in mind, we keep our program for example, every year we publish the standards roadmap, and also we support. We provide some consulting service to our SMEs, and then nowadays the international cooperation is also important. So domestic level we support our ICT forums, and we operating national committees, and then nowadays we are quite facilitating some link between national R&D and standards. And then international level, now we are some trying to renewing our some MOUs with 29 organizations overseas. And this is kind of some our activities for the global standardization. And then for the specific for B5G and 6G standardization, we maintain our work programs. First, we develop the TTA standards through the operation of TTA committees, and then through them we also make some international regional standardization collaboration. And second, we collaborate with the ICT Forum in Korea. Just mainly we adopt a forum specification to TTA standards. And third, we every year publish some standardization strategy, specify the key topics for 5G advanced and 6G standardization. And recently we started some government project which called this 6G standards research laboratory project, focusing on some activities of IQ IMT 2030 standardization. And lastly, as some operational partner, 3GPP, we do our job, and also we proponent for some IQ IMT recommendation. This is kind of some our work programs. Next, I will introduce more detailed information for each work items. This chart shows our some standardization committee structure. Actually, we have some technical assembly, and then under the technical assembly, 8 technical committees, and we have our 55 project groups. Normally, project groups developed TTA standards, and then technical committee adopted their some drafted TTA standards, and finally some technical assembly approved the TTA standards just twice in a year. And then among 8 technical committees, we have the code name is TC11, which is covering mobile communication with their project groups. Just to look at our status, our members is now over 269 members joined in this TTA standardization process. And then now the total TTA standard accumulated number is over 26,000 standards. But most TTA standards is coming from the 3GPP specification. This is over 70% of them. This is a chart. It shows TC11 and their project groups. Let's closer look at some roles of project groups. Project group PG1101 is mainly, they focus on some I2R IMT standardization. For IMT standardization, they usually have a joint meeting with other Asia SDO, which is Korea in TTA and Japan in RIB and China and CCSA. Normally, they are trying to make a joint contribution to Working Party 5D. And they also, study the future technology trends, and then they developed some report and TTA standards. And then PG1102 and PG1103 they in charge of RAN and network aspects, and they mostly they focus on some transposing 3GPP specification to the TTA standards. And also they developed their some pure TTA standards. For example, open frontal interface standards, which is based on the old specification. Normally, no old specification is have a lot of some options. So among our operators, we choose some commonality, and then we select down selecting some functions from the old specification, and then we publish the TTA standards. That is quite one of the example for the PG1102. And then 1103 also developing their some own standardization on NFV and MEC, something like that. And then we have a PG1104. That is a 5G vertical service framework project groups. They studied some use cases and some use cases for 5G verticals, and they're trying to develop the TTA standards, some common requirement for them. And nowadays they focus on C-V2X requirements for implementing in Korea. And then PG1105, that is a mobile communication service project group. They focusing on some mobile application service technologies such as voice over LTE and ICS, rich communication suite. And then through TC11, we facilitate some international and regional standardization collaboration. For example, the CJK IMT work groups, which is among CJK members discussing, share their IMT issues, and then prepare the joint contribution to I2R Working Party 5D. Then we also continue some joint workshop with TICS, which is a Taiwan Association of Information and Communication Standards. Actually, the TICS is not some member of some 3GPP organization. So with this workshop, we changed our views for some release planning of 3GPP. And then our other type of our international cooperation is we have a TK artist workshop. We had a conference call 2 years ago. And then we also have our Korea EU and Korea Australia conference annually. And then TTA also have our big conference, which called this GISC, Global ICT Standards Conference. During the conference, we have some 3GPP event which called is a 3GPP inside the event. Yeah, so this is kind of some global cooperation activities. And then DTA also work with the ICT fora. So we support our ICT fora. The total number is 30. And then the rating 60 matters. We have a 6G forum and ORIA, which is Open Land Industry Association in Korea. And also we support a satellite communication forum from 2021. Normally, we just support fund them and then facilitate the forum developing their forum standards and then promoting domestic and international some activities. But as you see very early presentation from Kyung-hee Chang, 6G forum is quite big and maybe they don't need our support, but we keep very close working for standardization area. And also, TTA publish a standardization strategy every year. We selected some 6+6 technology, 6 digital innovative technologies, and also 6 digital infra technologies. The first step, we analyzing ICT R&D budget status, and then in the step 2, we investing policy and technology trends, and then in the step 3, we examine the global ongoing activity, and lastly, step 4, we selecting the standardization target area based on the opinions of standardization experts through a survey process. So following presentation is kind of 6G 60 part. We also have it's kind of some process. So until 2027, and then we provide some implementation strategy on the policy, regulation, and R&D and standardization part. And this is one of the example for the 6G area. We analysis and surveyed from our expert and then showing some items in this screen. And then x-axis is indicated technology readiness level, and then y-axis is indicating competencies of Korea. So as you see, the CV text and IoT communication and other some edge computing and RAN enhancement is a quite good position. Further some readiness and competencies aspects. And then 6G core technologies is now early stages, so it requires some R&Ds. So this strategy roadmap shows also some 6G key items for the standardization. So we actually provided this kind of a strategy map to R&D side and then shared some industry for facilitating standardization. And also we recently some government project which called this 6G standard research laboratory project. And TTA and Entry and Korea University participating this project from 2021 to 2028. It's quite a long-term project because this project is focusing ITO, IMT 2030 some activities. So this normally some government project is for 3 years or 5 years is normal, but this project is quite a long project and then proposed to reflecting our national R&D and academia and industry requirements on our 6G into 6G standardization process. So we developing each task of some ITOR working packet 5B. And this is one of our we actively participate to develop some 6G vision in ITU. And so this is last year we published some 6G vision. We also reflecting our some requirements to this vision. And also, yeah, this vision is include some capabilities, training capabilities, and 13 is coming from the 5G, but in the 6G, we developed 7 new capabilities. So we developing more in the upcoming Working 25 meetings. And the important thing is in the capability is there are, you can see that some landmark some KPI, which is not yet decided some specific number. It was quite, difficult during the meeting. So we just captured some examples and then we call it 6G vision research target values. So we'll continue to develop these KPIs as well. And then last Working 25 meeting in March, we provided some logical approach. We provided some mapping table between capabilities and then usage scenarios for the work. So this is one of the some Korean contribution. And yeah, it's almost done. Lastly, 3GPP activities. As a 3GPP operational partners, we are now progressing on preparation such a 3GPP meetings. On May meeting, we have some 3GPP SA working group meetings in Jeju, Korea. We'll start some release 19 and also starting the discussion on 6G use case. So this meeting is quite important in this year for the 6G some use cases. And then next year, 2025, we are also preparing on hosting the 3GPP TSG meeting on March. Maybe the venue will be announced soon. But in this TSG meeting, we'll have a 6G workshop as well. So now we are communicating with some TSG chairmen for organizing 6G workshop as well. And then the new range leadership also election also in the next year after year 1 leadership. And then this is kind of some OP activities. And then now 3GPP TSG will discuss and design some release 21 6G specifications, some timeline. That is a hot issue as far as I know under the 3GPP meetings. And now the initial plan was set up, but the last some timeline to be decided to the later than June 2026. And then TTA actually members feel that are completing stage 3 by the end of 2028 is necessary to align with their IMT 2030 timeline. So our members is want to keep those timeline for stable IMT 20 some process. Yeah, this it is my last slide. As I presented the TTA activities, we are very trying to try to facilitate international cooperation. So it's a very easy way is participating in supporting expert involvement in 6G related and events which are organized both sides, 6G forum and NGA and TTA artists. And one of the example is TTA also have some big conference, GISC and 3GPP event. So we may think about it, and then also 6G forum have a lot of some activities. So we using them maybe regular meeting would be a very nice opportunity for both parties, I think. And then also we have some for the success of 6G process in ITGO and 3GPP. Maybe 6G release training work item is quite important. Also 3GPP timeline for release training also important issue. So we are maybe discussing and exchange our views on defining some mutual interest or some core common understanding will be for our some activities in the future. Yeah, let's see. Thank you.
Hey, thank you. And now, Wanshi, can you? We'll have discussion at the end if we have any time before our next session.
See when it works. If I find it. Okay, it's a pleasure to be here. My name is Wanshi. I'm currently Grandparent Chair. So I'll give you some summary about where we stand now in 3GPP. Particularly, I'll start with a quick overview about RIS 18 and RIS 19 before we talk about 6G initial timeline. I think also important because whatever we're gonna do for 6G has to be from somewhere, and we have RIS 19, RIS 18 now. Something we call 5G advanced is also not just provide this to address the commercial needs for 5G advanced. At the same time, also apply some projects which they're very good foundation for 6G. So it's very important to also understand that. So I'll start with the overview. This picture tries to show you where we stand in terms of all the different releases in 3GPP for 5G and 5G advanced. As you can see, we had 3 releases as part of the more like the initial phase of 5G, 15, 16, 17. Of course, the first release is really more like foundational, provide all the basic stuff, very flexible framework for us to build upon. And then we have release 16, release 17, which not only try to enhance the traditional eMPB, but also expand the support to vertical domains, which cover a lot of things. I think you guys also discussed a little bit earlier. And then starting from release 18, which is more like a project starting from in the middle of the COVID. Now we already finished it. With the official freeze coming very soon. This is the first release for 5G advanced, for which we already start some projects, particularly some full release study, which I'm going to show you later. It's very important for us to understand better the future potentials and to establish the foundation for 6G. Release 19, we continue this trend. At the same time to even further expand the set of projects next to 6G. At the same time, the primary focus is still for 5G advanced commercial deployment. So here's the timeline. The primary it focuses on the RIS 18, RIS 19 to show you where we stand. As I said before, right now we're still in the mode of 5G advanced. We had an initial discussion on 6G, but the primary focus for us is still 5G advanced. So these pictures show you that we are now finishing the so-called functional freeze for the design in all the realm of groups. And then I aim to have the so-called S1.1 freeze in June this year. So this is more like the final version that can be fully implementable for commercial deployments. So this will be done in June. Everything on track. So I don't expect to see any surprises. So they should be fine. At the same time, you may also see from the figure, there's always some kind of overlap between different releases. So if you see in round 1, in particular, the functional freeze was done in September last year. But then the run to restaurant, all the function 3 was December last year. But run 1 already started with 19 in the first quarter of the year. While run 2 still spend time for the resetting method. So some kind of overlap, which is necessary. And for release 19, they plan to have an 18-month release. You can see from run 1 is from early this year until June 2025. These days are very important because it's going to count with 6G. So all the 6G timeline somehow is also built from this. And then run 4 for release 19 also staggered by 3 months with the code freeze to be done in December 2025. So here, just quickly show you on high level what we have for release 18. This is more like something we call the balanced evolution. This balanced evolution comes from 3 different aspects: mobile broadband versus further vertical expansion, because it's very important. Just give you a number. Before 5G kicks in CPP, we had about 300 to 500 people in round 1. Round 1 is the fiscal aid group, the largest working group in 3PP. The first meeting for 5G, we start to see about 500 people. Now it's more like 600 people or less. So part of this is because of what we did expansion. So it's very important to have this balanced evolution. At the same time, also, I mentioned a little bit earlier, the 5G advance not just to address immediate commercial needs, but also long-term, the 5G vision. And at the same time, also to have the balanced evolution for both device and network side, particularly from energy consumption perspective. So here the list of projects. This is a very not to be exhaustive, but rather to highlight a few projects. I won't go to details. Probably maybe in the past, maybe a little bit boring to you. So I'll skip these slides. I'd love to move to the next slides, which one is 19. On high level, we still carry the same theme that try to have the balanced evolution, but sometimes want to also provide bridge to 6G, because these release 19 will be the last release in 3PP, which will be fully dedicated to 5G advanced. Starting from release 20, we're going to have a parallel efforts for 5G advanced and 6G. So I'm going to show you some of the projects, but it's fair to say that there's quite a few projects which more like provides at least as for now, a study to see how they're gonna impact 5G advanced, how it could be useful for 6G. So here, a highlight of a few projects. As you can see on the leftmost column, we have this more or less the traditional, if you will, projects: MIMO, mobility, topology, and some MDT. So this is very, very closely connected with commerce departments. In the next column, we have a new project, which is a very interesting project called ambient IoT. So this is kind of expansion of what we can offer for the IT domain. So you understand we have the 4G eMTC never IoT involved in the 5G framework used for 5G. We also have the RedCap, which was starting from release 17, and then you read the campaigns. So these try to provide a rich support for a diverse IoT applications. Now we have ambient IoT, which is something completely new. It's still being a study for now, but with target to try to see whether we can finish study by December to see if we can possibly convert to the so-called application, which is the one that can be used for commercialization. And we have, of course, satellite evolution, which is very important. I think this is part of also the 6G framework, this ubiquitous connectivity. I think this is a critical component for that purpose. And XR. XR is very important for us now in 5G advanced. We have been already at the study release 17 and had some support release 18. Now we continue evolving in this front. Hopefully we can help somehow to find or to support the so-called potential killer use cases. This could be one of them. So it's very important for us to continue evolving this front. And then we have this green part. These are more like some new project, if you will. One is duplexing. I think it's been discussed in earlier. Right now we focus on the genome side, so-called subband FD. Essentially, basically, the transmission and reception can be done at the same time, but is orthogonal in frequency in different subbands. So it's full duplex, subband, full duplex. And then we have this so-called FR3 study. This is very important this is more like a very direct bridge to 6G. The spectrum for a new generation of standard is very critical. So it's important for us to understand better about the channel the channel characteristics of this particular spectrum. So they will also need this, to start even including near field all the kind of things. So this is part of the study. And integrated sensing communications, I think it's also been studied in many 6G forums. This is also now we also carry the study. Right now, just focus on channel modeling, but with the intention that we will look at the situation in September this year to see if we could further expand into some technical study also. And last column, the wireless AM machine learning. I think this part is, without a doubt, is critical. We have fully studying RIS 18 now. We have the specification work for RIS 19. This is going to be very important for us to learn the potential limitation of 5G advanced and how we could move towards so-called native interface for 6G. And then network 97, this is very important because as you can imagine, this is one of the KPIs that many operators care about. This is also important for so-called, to have sustainable operation. I think it's been worked on by, I know in GA by many working groups. So this is very important for us also to continue evolving in this front. We did find there are some kind of limitations that in 5G advanced, just because all the common signals are designed away to facilitate operation on both sides. But now if we want to try to save energies, there are some limitations we have to live with, meaning we cannot have some non-backward compatible design advanced. Maybe 6G will provide opportunity for this to see how could redesign things from scratch to better support in the front. And low power wake-up signal receiver. This is also important to further improve the battery consumption on the UV side. This is not just beneficial for IoT types applications, but also for smartphones. Okay, so let me then move to the 6G part. So I think special question on 5G part hopefully is not boring to you. Now on the 6G part, is without saying there's a lot of momentum now for 6G. I think you guys all know this. Different forums, different regions, and on 3GP side, definitely we expect to provide input to MT 2030, the submission process. I think this has been already being discussed. The first discussion is 3GP because it's important for us to keep focused for 5G advanced. So we try to keep the discussion or the interest level as manageable in 3GP, not to go too much distraction to the ongoing 5G advanced. So the first discussion September last year, this is triggered by the liaison from ITU, the 6G framework liaison. And this very limited discussion, but then in December last year, we did spend quite a good amount of time, not a lot, but a good amount of time to have some high-level agreements on how we should evolve 6G in 3GP. And just in March this year, 1 month before, then we have these additional details, which was a very involved discussion. You'll see the details, but discussion, a lot of discussion and a lot of different views, let's say, particularly from vendors versus operators, the quite different views, but we were able to converge to I'm not how to say, very detailed timeline, at least for now, for RIS 20. RIS 21 is still something to be seen. Okay, so maybe I go direct to the last slides. The last slide shows you all the details. I can verbally present you all the details. So First of all, we will have this 6G, the use case workshop. I think some of you will be there next week. This is so-called S1 workshop. This is the first opportunity to exchange ideas on high level, all these different user cases. And then the CPP-wide or the core TSG, as the more official workshop will be in March 2025. This will be in the first 2 days of the meeting week. So with that, we're going to have the regular panel meetings and CG workshop. The CG workshop will be the first 2 days, and panel will be the from Wednesday to Friday of the week. So the details for this workshop still being discussed. I also got query from a Korean friend to see how this should be organized. Still in discussion. I think the key question we're facing is whether the workshop should be organized as a single workshop, meaning run SICT combined into a single workshop, versus a parallel workshop. Imagine if we could have a run workshop and SI workshop in parallel. But these kind of details I'm still discussing with SICT tiers. It's no conclusion yet. Definitely we'll announce whenever it's ready. So that will be the workshop. And then we'll carry out the so-called 6G study. And the 6G study, we'll have this study on the run side, based on plenary side, focus on these more like high-level requirements, use cases, KPIs, all kind of things. While we're also going to have a study on the working group level, particularly for physical layers in run 1, and also run 2, run 3, run 4 will be also involved. The primary study is very important because this is, I think, frankly, this is the forum that many operators are willing to share their views. The operator typically a little bit less active in the working group meetings, but they are more active in the parent meetings. So this is a very important forum to get together to really finalize the requirements, use cases, KPIs, different things. But to that end, we're at round level going to do 2 different studies. One tied with so-called ITU study, because ITU now also discuss some KPIs. So we'll try to see how we can help from our end. So we're gonna have some early discussion in 3PP in RAN, starting from September to December this year, without any kind of official study discussion per se, but just have some contribution driven in September and December this year. And in December, then we'll try to prove a so-called study item with detailed description of scope, everything, primary focus on ITU topics. So that'll be the first step. And then in March next year, after the workshop, the workshop for the 6G workshop, we'll try to prove the run level study, which is more like a general study, including all the use case requirements, everything. So that will be the next step. So then, of course, whether we're going to have a single study item and how we're going to carry out the detail, that part still need to be discussed. And then we have working group level study, which will be approved in June next year. For round 1, we'll start from we'll start immediately after, like from August next year. And for run 2, run 3, run 4, it will start 3 months later. So it's still the 3 months staggering as we have as usual. And this study will be for 21 months. So it's a little bit different from the regular 18 months risk duration. One reason for that is because there's indeed a lot of thinking behind saying, this study, we shouldn't rush to conclude study. At the same time, it's also important to try to connect with ITU. That's really we have the 2 phase. At the same time, also 21 months. At the same time, in the same release, we'll have a budget advanced evolution. That part is still critical because we have to provide evolutions in the next few years before 6G kick in. So they're very, very important. But that part is still being discussed regarding whether we should have a budget advanced workshop, how we should split the time, because we're going to have parallel efforts on budget advanced and 6G. How we should split the time between budget advanced and 6G. that part still yet to be seen. We'll see. I mean, very likely that the split will be different for different working groups. For example, round one, maybe there should be more or less equal split, maybe. Maybe round three could spend more time for 6G, but these seem to be discussed. Whatever example I give you, just give example. It's not a consensus at this point. So and then these will be read 20 and read 21. I can see this in this bubble there. Is unclear at this point, the detailed timeline. But what's been clear that we're trying to make decision before or at or in June 2026. This is where the run level study on 6G will conclude. One reason for that, this is something I think for all of us to work on is also to make sure we can have a good story for 6G. This is very important. There's a lot of concerns, if you will, from the community. Especially in March, they have they provide a very valuable comments regarding how 6G should be like, and from their perspective, what they expect to see. But these things is still at the early stage. It's important for the community to convince to have convincing study to show 6G is indeed something good. So they're very important for all of us. So that's the one factor why we cannot make decision now for RIS 21 duration. But regardless, this only be made in before June 2026. And if anything, the code freeze for RIS 21 will not be earlier than March 2029. But it could be, my projection be somewhere there, March, or maybe later, a little bit later, but somewhere there. Something, it really depends on how well we can do the job in terms of the study. With that, I think that's the end of my presentation. Thank you.
Thank you. I see a quick question from Andy, another over here.
Yeah, so the workshop for the IMT 2030 use cases versus the workshop for 6G TSGs. I remember what it was like when we did the RAN workshop for 5G in Phoenix. Is that what you intend, that format, what you intend to be like the workshop for 6G TSGs? And then is the IMT 2030 use cases more like SA1 type of material? Like, what's the difference between the two?
You're talking about the one will happen next month, the SA1.
Yeah, the difference between
SA1, yeah, I mean, SA1 is, I think the important SA1 is it's more the first opportunity to share the views, not just from, it's CPP itself, but rather to collect inputs from regional standard groups, the different MIPs and different other organizations it's more information sharing to me at this point. This is also important for SA group to collect these inputs to see how to manage the SA1 project. Because SA1 typically start earlier than other working groups. Right? They need to start out with different use cases. So it's very important for that purpose. For the more, I won't say regular, I need to find a good word, but you see what I'm saying, though. For the more general style, let's say, these will be similar to Phoenix. The one we're going to have in March 2025 will be the one mimic the Phoenix one for 5G.
So NGA will not have a presentation, or the regional alliances will not have a presentation in the 6G issue.
It's something I need to check more carefully, but I don't think the regional alliance was invited for the Phoenix workshop. So this is more like from all the individual companies, from operator side, vendor side, vertical domain, and we try to.
There were no MRPs or PCGs.
I don't think. But we may receive liaisons. So that's a different story.
And then we have another question here from Jared.
Yeah, when it comes to let's assume the situation of the earliest time of release 21 AS and data operating time is March 2029. In there, we also take into account this 21 month release 20 period and the RAN 1 as well as the RAN 234. And we only have some, when considering the 3 months or 6 months of gap between the functional freezing and the AS11 freezing. And we only have some, when it comes to the RAM 234, only have some 12 months or 15 months duration toward some. I'm not pretty sure about that.
I think it's still 18 months, if I'm not mistaken.
18 months.
Yeah.
It's provided.
Yeah. So it's more like if you can think, because I believe from March 2029 to the release 19 functional freeze.
When it comes to the 2027 and then the
So
2028 June time or September time, I'm not pretty sure. September or December, yeah.
At least the last time checked, there's more like 39 months gap between this 19 versus 21 freeze. So we either do 21 plus 18 or 18 plus 21. Now we do 21 months of this study. Likely we're gonna do 18 months for the 21. But do you think it's still too early to say? It could be 21 plus 18, it could be 21 plus 21 or 24, 27, who knows at this point. But I think it's 18 months, it's not that long.
Actually, to my understanding on the some required workload, even in the some really RAM 2 and 3 and 4,
yeah,
it should be some very tight schedule, even with the some earliest time of release 21 AS11 target. March 20.
I think the one thing I think we need to figure out in 6G is that in the first release, the specification release was 21. What should be there? If we still put everything in 321, then 18 months can be very tough. But if you do a good job to put only the ones that we believe that gonna bring the immediate commercial benefit there, then 18 months is still okay. So I mean that's the part of the reason we cannot put design now. It had to be started to see as part of study actually what should be the feature that we have to specify in this 21 of 16.
So sure. If we look at the 5G standard, the amount of specification is huge, and the specification has lots of features and options, probably to support lots of various verticals, probably. But actually, the real deployment, not many of them have them implemented. And in 6G, ITR is now defining 6 usage scenarios. So I expect 6G will become more complex, and with lots of functions to support this 6 usage scenarios, various usage scenarios. So what would you say were in terms of standardization efforts? How like to maybe from your company perspective proceed with the 6G? Considering that we already have very complex specification 5G and all, but not actually implemented.
This is an excellent question. I mean, this is
yeah, I think actually we're going to have to table this discussion and maybe have it over cocktails later.
Yeah, I think very good idea.
Because we need to move on with the rest of the agenda. But thank you, Wanshi, very much. Very interesting and thought-provoking, and clearly more conversation to come.
Yeah, thank you so much.
All right, I think we're going to move into the open RAN discussion, and let's start with Yonki. Okay. Thank you.
And not just that,
Nice to meet you. My name is Yong-Hun Kang. I'm CTO of Solid Americas. I'm in charge of the product and technology roadmap and growth strategy in Solid, based in Plano, Texas. Today, I want to briefly introduce who Solid is. For some of you are here Solid name first time. And also I will touch my thoughts regarding Open RAN and network sharing. But my presentation will not be a technical deep dive into the technology RAN standard, But rather than instead of it, I'm sharing my thoughts regarding at a high level, considering how these technical components collectively contribute in network evolution toward the green communication and sustainability. The Solid is 25-year-old communication equipment vendor in wireline wireless industry. So we are actively doing the business in the United States and Europe, as well as South Korea and Japan. The major global MNOs operators are our customers, but also 3POs, so-called neutral hosts, is one of our key customers who will do the critical role in implementing network sharing. I will share the details later. And we have many global landmark e-building sites where our systems are installed and support multi-operators mobile services inside the building, such like the Empire State Building, JFK Airport, and Metro. This is the product portfolio, but I wanted to focus today regarding the neutral stats as one of the platforms for the network sharing, combining the standard RAN, Earth, and the other thing outside of the standard in order to achieve the green communications. Let's start with function split. So we all know the only function split defined in 4GLP there was, but not completely open or interoperable. But the new function split in 5G is aggregating the major function blocks into central unit, distributed, and radio unit. This is kind of the foundation of the current Open RAN mainstream. So Open RAN is standardizing these interface defined by 3GPP to interop between the multiple vendors. So RAN Alliance, formerly XRAN, first focused on the frontal space standardization, but now they're actively working on almost all the major interfaces in RAN. There's some facts regarding Open RAN Alliance. I don't touch the details, but the one thing I have to mention here is Open RAN Alliance vision, which was presented by Jin Sung Choi, the chairman of the Open RAN Alliance at WC Barcelona this year. Openness, intelligence, and virtualizations. How once the Open RAN achieve these missions, the result might be explain some of keywords. But one keyword I wanted to introduce here is higher efficiency that the openness and interoperability bring into by building up the new ecosystem for the lower price and high performance and acceleration of the virtualizations and bringing in innovation. There's a long way to go to achieve these goals, but once we achieve this kind of higher efficiency, that means lead to the lower TCO. TCO is total cost of the ownership, the CAPEX and OPEX. Let's see one of the example from the NTT Docomo in Japan regarding the TCO compositions. In the CAPEX side, RAN, radio antenna is the major portions. In OPEX side, site rental and electricity is the major portion. So in order to achieve the lower TCO, it is very sufficient to focus on these key parts, RAN, radio, and energy consumptions. Then I want to talk about a little more regarding the RAN sharing in order to achieve the lower TCO eventually to green communication and sustainabilities. There are so many challenges in the network deployments and operations. So higher cost for auction, frequency auction, and constructions, and higher energy cost. And as complexity systems goes up, adding new bands, the active antenna with different type of systems, and also space limit, especially in the urban areas, the limitations on the size, weight, and also energy consumptions. So all these are leading to the higher TCO. Then there are some ways to lower the TCO, but I'm talking about network sharing is one of the keywords to reduce the TCO by sharing the resources. What the shared resource is baseband, hot server, and data center space, one of it, and radio, power amplifier enclosure, power, antenna, passives can be shared throughout the network sharing. and also construction operation and frontal could be shared. One example of the power, reducing the TCO is reducing power consumption. See, total mobile, 70% of total network energy consumption consumed by the WAN side. 70%, 75 to 97% of the WAN energy consumed by the radio. So the WAN and radio is key parts in order to lower the TCO. So let's focus on the radio parts. That's the remaining presentation. So these are eventually go to the green communication and sustainability. Then I keep saying network sharing. So what difference between network sharing versus RAN sharing? Your RAN standards are familiar with the RAN sharing, but RAN is key part of the cellular network, but not all of it. So network includes all the other parts of other than the RAN, operation, construction, operation, site, space, active task, etc. So the network sharing, in some sense, could be a superset of the RAN sharing. So in terms of the RAN sharing, defined in 4G, 5G, and Open RAN, they're roaming the different technology I will introduce later. But there is another part of network sharing out of the standardization. The one conventional example is outdoor tower sharing. And also neutral host system accommodate multiple operators RAN signal in a single platform in the building environment would be another example, which I will show you later. So you are very familiar with these diagrams, but I want to focus on the MORAN. Why MORAN is different from the MOCN. MORAN has dedicated core and spectrum for each operator's WAN strategy, but while sharing the WAN part for the efficiency. But as you notice, this diagram is assuming only one type, E node B, G node B, just one body. But once this function split is introduced in this diagram, other options in the MORAN could be possible. For example, CUDU, at the dedicated CUD chipper that has the radio could be shared. So there's one of the RAN sharing technology called shared OIU by ORAN Alliance. The three diagrams, enough of the details, but the key in shared OIU discussion, ORAN Alliance, how to manage two operators, how to manage one single radio, that's the key. The other CUS plane is not critical. So here the shared OIU host has direct control the shared OIU, but not belong to any operator's RAN network. So independent shared OIU host, that's the left side structure. But the other two structures, this shared OIU host belong to one side of the operator's RAN. So different types is that our hybrid approach means that this shared OIU host directed communication to the shared OIU versus hierarchical approach that the shared OIU host goes through the DU to control the OIUs. These are the technical discussion in ORAN regarding the shared OIU. Then another topic I wanted to introduce is in-building application. Why? There's two reasons. The first reason is most of the data usage recently happens in in-building environments. And also the in-building environment is quite different from the macro environments in terms of the different limitations like the walls, ceilings, bottoms, and the small but open area like the stadium, subways. These kind of different environments needs a kind of specific optimized solutions. One of it is neutral host DAS. DAS is very simple structure. It has hub and radios. Hub accommodate the RAN signals from the operator's base station and deliver to the multiple radio and transmit to the antenna throughout all the in-building applications. But key feature here is neutral host means that DAS hub accommodate multiple RAN signals from the multiple operators. So they combine these multiple RAN operator signals into one single stream, deliver the radio, multiple radio, and transmit through the antennas. So it's kind of the network sharing between multiple operators. So then how these MORAN, ORAN, and neutral stars could contribute in network evolution. So the three terminologies I choose. So why MORAN with again, MORAN has different options, sharing all the RAN, but I'm showing here the MORAN with the radio share only. Please see this very simple diagram. Right hand shows everything is shared and roaming, or to spectrum everything. So could be the maximized efficiency, but there's no operator's independence. The other extreme, the left side, nothing shared, or the separate network. So network operators' independence could be maximized, nothing shared, efficiency low. So one option I wanted to discuss today is somewhere in the middle to not maximize, but have the major portion of network efficiency while ensuring each operator's independence. That's the scheme I want to discuss from now with a couple of the slides that remain. So more with radio. So keep focusing on the radio sharing because the radio is key part of the RAN, but still giving the dedicated spectrum baseband to each operator. In order that each operator have its own network sharing network strategy, like the network RAN implementation, capacity location and KPIs, and so etc. So why ORAN? ORAN is one of the technology, the open interface interoperability for the sharing RAN in the MORAN scheme. Then neutral DAS is again could be network sharing platform with a single platform support multiple RAN signals between each operator RAN and the unit. I think this is the last slide for the main presentations. So this is one of the example network architecture collaborating MORAN, ORAN, and neutral staff. So again, the dedicated resources are the core, backhaul, and also baseband, CUDU, and spectrum, owned and operated by each operator. Frontal could be shared or dedicated depending on the implementation. But the shared OIU, the key part of the radio is shared by multiple operators based on the technology called shared OIU defined by ORAN lines. There's another option that without neutral staff, shared OIU could support the radio service into the building. So that's one option. But I think the neutral host is specialized and optimized to deliver wideband signal of the multi-operators into the building. So that's why I'm introducing the scheme using the neutral DAS. So neutral DAS is one single platform for network sharing for multi-operation, multi-operator, and multi-band. So flexibility, scalability. So neutral is not a standardized using the standard interface. So it's very proprietary interface, but that's why it could be optimized to deliver multi-operational, multi-band signal efficiently and cost-effectively. Okay, so there's a small short presentation, but I want to summarize. So all know that the environment sustainability is critical in 6G and network evolution. So I've shared my thoughts that network sharing is one of the ways to achieve this environmental sustainability. So our further discussion regarding network evolution in 6G definitely will include the RAN itself, but also ecosystem, hopefully could impact the network sharing as well. Thank you very much for your attention.
Thank you, and we have to move right on. So Hagesh, can you step up, please?
Okay, yeah, thank you. Thanks for the very nice talk. Maybe I should start with saying that this talk will be probably at an even more high level. in the presenting NGA's views, and then NGA's views kind of focus more on the broad directions rather than on the details. So I'll start with the audacious goals that we have and say a little bit about the relevance to this part about Open RAN. Just look at the mobile network journey in general, the role disaggregation is playing increasingly as we go forward. And some key aspects of Open RAN that will also influence 6G. So let's go to the goals here. So I think David already touched upon these 6 audacious goals, so I won't go over that. But one thing I just want to point out here is that how this maps to the usage scenarios of the that have been identified by the ITU. So as you can see in the usage scenarios that they've identified, I want to focus on this external ring where they have identified these overarching aspects: sustainability, connecting the unconnected, security, resilience, and ubiquitous intelligence. And interestingly, 4 of the goals that have been identified by the NGA kind of match actually with these overarching aspects. And so one thing to point out here is that the story of network disaggregation in Open RAN is also that type of an overarching aspect. It is something that has been transforming networks even in 5G, and it's a constant evolution. And we expect that evolution to continue in 6G. So if you look at mobile networks in general, right now we talk about Open RAN and openness. But in the NGA, in the original technology working group report itself, they've kind of pointed out that open and interoperable standards are in forums such as ITU and 3GPP have been at the heart of the baseline interoperability that makes the whole system tick. And initially, of course, with 2G, we started off with digitizing voice, and voice was the main service. But over all the generations, we have had quite a bit of evolution on use cases and services as well. And then the network itself has evolved quite a bit as well. So, you know, as mobile systems have developed in parallel, cloud systems and cloud technologies have progressed as well. And all of these, so the ways in which mobile networks are deployed, developed, is changing also, and the network is constantly evolving. And when it comes to, and a big part of this evolution on the network side is essentially what we call disaggregation. So disaggregation in its broadest form is deconstruction of any kind of monolithic networking system into separate components or subsystems, so that these can be evolved independently and could also be based on different technology choices or even have different vendors. So the and first, of course, standards are essential to that disaggregation. They lay the foundation, and increasingly we are seeing an evolution of that. And the advantages of this kind of disintegration are basically some greater flexibility, scalability, reduced cost, as well as vendor diversity. Of course, there are challenges as well. When we have more entities that are creating a network, then we have additional complexity of integrating all of these components from diverse sources, assignment, distribution, and management of resources, and accountability for any failure in the system. Who takes account of that and fixes the issue? But in general, we see that there is this trend towards network disaggregation. So many technologies like software-defined networking, network function virtualization, containerization, in general, the cloudification of the network, and also the whole open source ecosystem, as was pointed out earlier as well. Open interfaces in the RAN and the core network all are creating this kind of trend towards network disaggregation, which, as I pointed out, is also affecting how 5G networks are developed. So again, I think the dimensions along which we can disaggregate components. So one is on hardware and software level. So you can have different entities kind of developing those two platforms. You can also have disaggregation along the lines of user control and management thing. So different paths to developing all of those parts. And then finally, also in terms of network functions. So we can disaggregate the RAN into components that implement discrete functions at different network layers. So you can have RUs, DUs, and CUs as pointed out. So in the RAN disaggregation story, you can see that we basically have different ways of deploying radio access network. And early on, even in 4G and so on, we have actually had the concept of the distributed RAN. So conventional distributed RAN, we would have the radio unit and the baseband processing kind of separately. But then with the uptake of cloud technologies, we kind of move into the domain where the baseband processing is now implemented on some kind of cloud platform. We are now increasingly moving into a world where things are split up into the radio unit, the DU and the CU can all be placed in different places and developed independently. With now the CU also being supporting radio interface controller platform where you can have apps running on top of this controller so that you can have more easy, diverse management of the network function. So yeah, and I should say that maybe just go back to this slide. The important thing to recognize here is that from a standards perspective, this is happening in multiple places today. It's in ORAN, BGP, PM forum, HC as well. So some of the key aspects to note here are that, so when it comes to Open RAN, I mean, some of the key aspects here are that the radio layer is basically being separated out so that if we, with an open front haul or a packet-based front haul, it allows us to have arbitrary replacement of the DU and the RU. So that is one key part of the Open RAN based system. Another is essentially instantiation and control of entities using a service management and orchestration function. So controlling the network with this framework. And then finally, having a radio interface controller platform to provide this kind of coordinated, automated management. And the key part with this kind of platform is that you can have a diverse array of software vendors providing interface. So I'll just end with this last slide. So I think, so how does all of these trends that we have identified and these different aspects play into the 6G story? So I think the key thing here is that, as I said, because this is more like an overarching aspect that underlies everything else. So just as in the case of sustainability, we will continue to make progress, but sustainability will kind of infuse everything, all aspects of 6G. So we see that the way networks are being built is being transformed, and that transformation will continue into 6G. Disaggregation will continue to play a key role. Additional management plane functions that enrich the network through standardized interfaces will continue to play a key role. More efficient implementations of network functions. And in general, this trend towards Open RAN is strengthened by industry trends that are adjacent to our world. So, for example, all the commercial cloud platforms and the increasing proliferation of that. Then the ability to do more hardware acceleration in customized ways, and also to be able to run cloud runtime on specific hardware independently with different entities doing. I think this is all of these are trends that will continue to strengthen Open RAN. And it will also Open RAN will also play a very key role in AI/ML and the ability of AI/ML through lifecycle management and model training, inference, etc., to be able to manage the network in a better way. And I think the key thing I would end with is that, as we have noted in the GA, especially when we started working on management and orchestration recently in the technology working group, alignment between all of the different involved standards organization starts to become even more important as we go to 6G. And I think a key thing to figure out is how do we make all of that happen so that we have one well-functioning system based on these principles. Stop.
Thank you, Hamish. We're going to go straight now into the spectrum topic, and we're going to start with a video from Sung Hoon Kwang.
No. It will be given the videos. We will supply the video clips.
Yes.
Right?
Yes.
Yeah.
Hello, I am Professor. Professor Sung Hwang from Dongguk University, Seoul, Korea, who is a chairperson of 6G Forum's Spectral Committee. First of all, I am sorry that I couldn't attend the joint workshop between NextG Alliance and 6G Forum, but I am happy to introduce the spectrum status and issues in Korea through this video clip. Here are the contents. First, I would like to introduce the Spectrum Committee in 6G Forum. And then I'm gonna talk about the spectrum strategy and 5G status in Korea. After introducing the digital spectrum plan, which will be officially announced in May this year, I would like to summarize the collaboration items between NGA and 6G Forum. A Spectrum Committee in 6G Forum. 6G Forum started from a 5G Forum. The Spectrum Committee has been responsible for investigating the issues on frequency spectrum ranging over low, mid, and high bands for 5G and 6G mobile communication system to support both legacy and new services. Here are three goals for Spectrum Committee. First, analysis of 6G candidate frequency spectrum. Second, analysis of traffic and bandwidth according to 5G and 6G applications and services. Finally, the research on frequency efficient technologies. For the organization, I'm the chairperson. We have 4 vice chairs from KT, SKT, Ericsson LG, and Samsung Electronics. More than 30 members are attending from more than 15 companies. The Spectrum Committee is collaborating with government, forum, academia, and industry. To this end, the Spectrum Committee holds the regular meeting every 2 months and publish the issue report every year. Additionally, we have workshops, seminars, and special meetings. For example, In January this year, 6G Open Symposium was held to share the knowledge and information regarding WRC 23. These three are the goals for Spectrum Committee, and activity direction and activity plans are described in more details. I'd like to skip these parts. I would like to introduce the spectrum strategy and 5G status in Korea. This slide shows the history of spectrum strategy in Korea. In the meantime, the Korean government proposed 4 spectrum plans: mobile spectrum 1.0, 2.0, KICT spectrum, and 5G plus spectrum. Through the mobile spectrum 1.0 in 2012 and mobile spectrum 2.0 in 2013, 1.8 gigahertz and 2.6 gigahertz frequency band were provided for LTE respectively. Through the KICT spectrum in 2017, 3.5 gigahertz was provided for 5G NR applications. Also, through the 5G plus spectrum in 2019, 6 gigahertz was supplied for unlicensed services, and 4.8 gigahertz was provided for EUM 5G. In 2024, based on the Digital Bill of Rights, the digital spectrum plan will be announced officially in May. This slide shows the current status of 5G base station deployment and evolution plan. On the left figure, we can see the base station deployment. The red color shows 5G base station deployment area. In 2022, the 5G base station deployment was built around large cities, but the coverage was built nationwide in 2024. Based on this national network, it is expected to evolve into voice over new radio carrier aggregation, and open RAN for the future. Local 5G is also called EUM 5G in Korea. Local 5G has another name such as private 5G, campus 5G, and non-public network. Local 5G is a customized 5G network for special purpose over local area such as in building. EUM 5G. EUM is named from the initials of 5G usage scenarios eMBB, URLLC, MMTC. Also, eum means connection among human beings and things in Korean language. For eum 5G, 600 megahertz bandwidth was provided at 28 gigahertz. Also, 100 megahertz bandwidth was provided at 4.7 gigahertz. There are several applications of eum 5G, such as smart factory, remote operation, AR/VR in venue, and education using AR/VR. To promote 28 gigahertz frequency band, new 5G operator appeared in Korea in January 2024. The company name is Stage X. As an anchor frequency, 20 megahertz bandwidth was supplied at 700 megahertz frequency band. Also, 800 megahertz bandwidth was provided at 26 gigahertz frequency band. For your information, the frequency allocation price started at 53 million US dollars and ended at 300 million US dollars. According to WRC 23 decision, 6 gigahertz is used for a wireless local area network. The Korean government wants to expand the usage of Wi-Fi 6 and plan to employ Wi-Fi 7 in 2024. Therefore, Wi-Fi 6 needs 160 megahertz bandwidth and Wi-Fi 7 needs 320 megahertz frequency band. Now, I would like to introduce the digital spectrum plan of Korean government. The contents was based on the presentation in January this year at the public hearing. Officially, this plan will be announced in May 2024. The first strategy is to improve the utilization efficiency of entire mobile communication frequency band. To this end, the government plans to promote the balanced frequency supply for low, medium, and high bands, open the mobile communication frequencies to all fields such as non-mobile telecommunication sectors, and to supply with priority given to wideband utilization. The second strategy is about the promotion of securing 6G frequencies for global market leadership. The government plans to promote the international cooperation and response, such as ITU and 3GPP. To discover the balanced frequencies in low, medium, and high frequency bands, and discover 6G candidate bands in new bands discovered and studied by ITU and existing bands used through the mobile communications. For WRC 27, as a 6G frequency band, 4 bands will be studied in 4.4 to 4.8 gigahertz, 7.125 to 8.4 gigahertz, and 14.8 to 15.35 gigahertz. Also, for the mobile satellite services, the existing frequency band will be studied. This slide shows WRC 27 agenda for IMT frequencies. The 3 frequency bands mentioned in previous slide are marked with a red dotted box, which shows in line with Korea's position. This slide shows WRC 27 agenda for mobile satellite services. From 698 megahertz to 2.7 gigahertz will be studied for WRC 27. The third strategy is about timely provision of frequencies to support the growth of new industries. For example, to demonstrate the UAM experiment, the government plans to supply 6 megahertz bandwidth and 30 megahertz bandwidth. Additionally, for the ultra-low delay services, such as 5G VTX in the 5.9 gigahertz frequency band, the government plans to secure 40 megahertz bandwidth at least for collecting and transmitting traffic information. The final strategy is about the innovation of industrial and daily wireless services using unlicensed frequency band. For wireless local area network, the government plans to expand the channel bandwidth through the introduction of Wi-Fi 7. Collaboration items. Before proposing the collaboration items, I would like to introduce 6G R&D directions in Korea. 6G R&D program will be newly launched in 2024 this year. It will be continued for 5 years' time. Among the technologies for 6G, The advanced wireless technology for upper mid-band energy saving technologies for AI low power technology and high efficiency technology would be good candidates, good items for the collaborations. In summary, the research on the upper midband and the related WRC 27 agenda items, the research on the energy saving and frequency efficient technologies, and joint work to secure a balanced frequency in an entire band will be required. Thank you for your listening. Thank you.
Today had to be approved by the Next G Alliance members in order to be shown on the screen. I chose not to use slides so that I didn't have to get anything approved. The people in the Next G Alliance. I like to have a little fun, and it's not a good meeting unless there's a little bit of controversy. So I will talk about, a few of the things that my working group has done, and it's great to see what I think, at least in my mind, is a healthy amount of alignment, and how your spectrum committee is looking at, what some of the challenges are and what some of the interesting spectrum bands are. Certainly what we're doing in the Next G Alliance as well. The first deliverable that we put out is considerations for 6G. I encourage you to go download it, right? There's a lot of it that's just not going to be that important to Korea because it is an analysis of all the potential spectrum bands for 6G in North America. So you can, faithfully ignore that. But the thing that's interesting about it are some of the challenges that we will face in some of the spectrum bands in North America with our ability to actually deploy 6G or even use some of that spectrum for commercial mobile broadband, and because of some of the incumbent user systems that are sitting inside that spectrum. So I think that is probably the most interesting aspect of that first deliverable, because it exposes some of the challenges that my working group is facing when we're trying to figure out how to evolve commercial mobile broadband right from 5G to 6G. One of the things, anecdotally that we've done, in my company is, when you look at spectrum, how much spectrum has been dedicated to any one G from 2G through 5G, and I said this to Ting Feng earlier today. Our calculations show that typically every G needs about 80+% more spectrum than the prior G. And one of the things that at least worries me a little bit and presents a challenge that I think that we can actually address is that if there's any expectation of mobility in 6G, and if there's any expectation of not densifying the networks to the point where nobody can afford to deploy it, meaning basically less than 10 gigahertz from a macro network population coverage perspective, there's not enough spectrum, sub 10 gigahertz, that could be cleared and licensed and then auctioned for operators in the United States. And so I'll come back to that point when I talk about my third deliverable. The second deliverable, right, that we have in the Spectrum Working Group that we're working on actively right now is the spectrum needs of 6G. Now, in a way, determining what you need, what spectrum needs are for 6G relies almost entirely on two sets of information. One is, what is the spectral efficiency of the radio system? The other is, what am I going to do with it? Like, what are the needs? In a lot of ways, and unfortunately, I'm going to miss tomorrow's conversation, right? I'm not sure that we're going to see a whole lot of additional spectral efficiency in 6G beyond what we have in 5G radio. And so, we've already, approached Shannon's limit to the point where I'm not sure, getting all the way there is going to be worth the money involved in trying to get there, because I don't think we'd be able to monetize it. And so that's one aspect of what drives answering the question, how much spectrum do I need for 6G? The other is based on the great work that Kadang's working group did, which is what are the applications and services, right, that we're going to do for 6G? Now, Kadang's team did a wonderful job providing us with a lot of information. One of the things, that I think is always interesting when talking about applications and services for 6G is that we still don't know what we're doing with 5G. For better or worse, the best application I can think of for my cell phone right now for 5G is I get better Netflix. But what that means is that when we're trying to really figure out what to do with 6G, it's a lot of speculation. And we need to be honest with ourselves that it's a lot of speculation. Every G is supposed to fulfill the promises of the prior G. Some of what we're seeing right in 6G applications and services are the things that we would have expected URLLC or MPC-based networks actually doing in 5G. And so we're basically shifting to the right some of the things that because operators haven't figured out how to monetize this stuff for 5G, we're moving it into 6G. The North American idiom here, to use JD's word, is we're kicking this can down the road, so that it's a problem for the future. And so we're calculating what the spectrum needs of 6G are going to be, and it's based on a really good set of information for speculative applications and services. Now, personally, I think for sure the one application that I don't think will be addressable, even if we satisfied everything we wanted to do with 5G, is mobile augmented reality. I quite simply don't think that would be possible on any deployed 5G network in North America today, because one, they're all eMBB based. And two, even if they were able to satisfy the ultra reliable latency requirements in order to not make people nauseous when they're wearing augmented reality goggles, because I don't know if you know this, 15% of the population are biologically impaired, right? When using VR or AR, they actually get sick. And so there's a biological problem with some of these applications and services, but even if it were possible, right, 5G I don't think would be capable of satisfying that particular application or service, right? And so I think, we have some really good, ideas of what we think 6G might be. But I'm going to talk in a minute about, well, I've got 10 minutes, so there's no questions to be asked. I'll talk about some of the challenges that we're facing, right, when it comes to how we're thinking about this. But suffice it to say, we're working on trying to get out the door sometime, if we're lucky, in the next 2 weeks, a document that talks about the spectrum needs for 6G. I will just tell you in advance that no matter what version of the document we put out, because we've had some last minute, we'll call them challenges, in the document, it's going to be a lot. It's either going to be all of the spectrum sub 10 gigahertz or some smaller, lesser amount. And so basically what that means is that there's the appetite for spectrum for 6G is going to be enormous. We don't really know what the traffic model is going to look like for 6G because we don't know what the business model is going to look like for 6G. Is every operator that is deployed 5G networks, that will deploy 6G networks, going to offer every service that people have come up with for 6G? Probably not. Are they going to offer all of those services on every type of, every different band? No, right? Some bands are more suitable for some applications and services than others. And so when we put our document out, I encourage you to read it. I encourage you to take it with a grain of salt because of the level of speculation that is going into our work. We're going to do the best job we can documenting our assumptions. But I think what it will do for you is it will paint a picture of the need. And we just need to be careful about treating the numbers as we would say as gospel, right? I mean, the numbers that we're going to publish in our document are going to be good numbers, but it's going to be based on speculation. And so that's the second deliverable that we're working on. The third deliverable that we're working on is spectrum access. And this is, honestly, this third deliverable is why I ran for Spectrum Working Group Chair in the first place. We have worked hard to talk about, and the way we talk about it in my working group is there's 3 different types of spectrum access. There's cleared licensed spectrum, there's shared licensed spectrum, and then there's unlicensed spectrum. Now, being where I'm from, right, I would really like to see, the United States and North America do a really good job of reinvigorating our telecommunications industrial base. And so I'll start with unlicensed spectrum. Right? The United States has more unlicensed spectrum than just about any other country in the world. And we do a really bad job of actually utilizing it. If you think about it, right, from a commercial mobile broadband perspective, if the best we can do is Wi-Fi offload, then we need to come up with more ways that we can leverage the fact that we have a huge amount of unlicensed spectrum. In the commercial mobile broadband industry, we tried. I was there when we standardized LTE-U. I was there when we standardized 5G and RU, right, the unlicensed versions of LTE and 5G to try to compete with Wi-Fi, right? That didn't go anywhere. And so figuring out a better way to use unlicensed spectrum, I think, is imperative. And I think it's imperative for every country, because figuring out a way to, and this is thematic for me, to leverage all 3 types of spectrum access at the same time and maximize the use of all 3 types of spectrum is going to be required in order to meet the spectrum needs based on the document you're going to see us publish. Right? So it's not just going to be one spectrum access solution that's going to be the way we do things. It'll be all of it. And so figuring out how to do a better job with unlicensed spectrum is important. Cleared licensed spectrum is, what every operator, right, that the commercial mobile broadband operator wants. They all want clear licensed spectrum. You'll hear our operator community and their manufacturers talk about the fact that the success of the United States building out commercial mobile broadband was based on the reliability and the certainty of cleared licensed spectrum. I can't disagree with that. But where we're at right now in terms of, thank you for taking the picture down. Based on the reality of where we're at, is that again, sub 10 gigahertz, when you look at the amount of spectrum that we're likely to need for mobility, and even looking north of 10 gigahertz, the incumbent radio systems that are sitting inside there are going to face challenges when it comes to being auctioned and cleared. We're going to see a point where, if we're not already there, where the cost of relocating a federal incumbent user is going to eclipse the value of the spectrum at auction, right? So it won't be worth it to try to move those users, which brings me to my favorite topic, shared spectrum. And so the way I have been working in the working group is to treat each type of spectrum access as equally important, and they are, right? The more we can do to evolve and make cleared licensed access better is good, right? Especially for the way we've licensed spectrum today, and likely how we will continue to license some aspects of spectrum in the future. Unlicensed spectrum, Team Pango and I were debating this outside. I think that from a regulatory perspective, we need to take a second look at how we actually regulate unlicensed spectrum. I think that despite the difficulty of the problem, right, using Wi-Fi spectrum only in the mechanism that we use it, for basically Wi-Fi access points in residential and in areas and such, is not the best use of that spectrum. We need to do that and other things. And then shared spectrum, right, is really, to me, the thing that probably needs the most attention. It's not that it's most important. It just probably needs more attention than cleared licensed and unlicensed. And this is where, I will observe a number of different things that the US government is doing, right, in the area of shared spectrum, to give you some indication of how important it is, right, that the US government has already recognized that shared spectrum is critically important. But also, some of my observations will expose some of the tensions that I see in the different business models, that are driving preferences for those 3 different types of spectrum access. And so what the point of that statement really is to think about it this way. There are externalities outside of spectrum efficiency and the applications and services that we'll use that will actually determine how much spectrum we have for 6G. It's going to be the business models, right? How can people figure out how to make money? How can the government make money by auctioning spectrum? How can a mobile network operator, create value, right, by using that spectrum? And so it's going to be things outside, right, of just the technical aspects of spectrum that drives innovation in spectrum access and actually drives how much spectrum is set aside for 6G. So one of the things that I will note, right, that I think is interesting, that we kind of talk around, but nobody has really puts a pin in it, is that, for 5G, what most operators are doing today is selling smartphone subscriptions. We have mostly unlimited plans and much bigger pipes than we did 15 years ago when I was paying for a cell phone subscription by the megabyte, right? So there was a direct correlation to how much an operator paid for the spectrum at auction and how much revenue they were generating in bits per hertz per second. Today, there's no longer a correlation. Arguably, they're underwater, right? It's everybody wants to pay less and have more bandwidth, and they no longer can correlate the value of the spectrum at auction. And that's just for a smartphone, right? So if we can't really generate new revenue with smartphones, where are we going to generate the revenue? And the reason why I'm talking about this is because I think this will definitely happen in 6G, and it will drive spectrum needs, which is it's going to be about devices that don't look like this, right? The 5G and 6G are going to, explode when it comes to things like massive IoT. Right? How many, I've seen speculation that each person at some point is going to be wearing 20 plus IoT devices, right? I can think of, I have at least 3 on me right now. Typically I have 5, right? So in the connectivity of those devices, right, and massive connectivity, getting after MMTC, which isn't where we are today, but a lot of really low bit rate, but a whole lot of really low bit rate devices will drive how spectrum access has to work to enable those things. And it will drive what the spectrum needs are if they can figure out how to monetize it, which means that figuring out how to get after things like reduced capability chipsets is a critical enabler for me to 6G, because it opens up an entirely new multiple sets of classes of devices that I think will be where the innovation happens in 5G and 6G, and thus drives the actual 6G spectrum needs. Now, the observations I was going to make. One, I already talked about this, the pressure from smartphone subscriptions and the lack of new revenue generation. The device ecosystem and chipset evolution, I think, is incredibly important. Right, I talked about federal incumbent users versus clear license spectrum, right, and the difficulty that we're going to face. And just as an example, right, trying to move naval radar systems, the amount of money it would take to do that would be in excess of tens, if not hundreds of billions of dollars, right? Just not going to happen. And so just the sheer amount of cost involved, but having spectrum that if you look at pure utilization, how often in any one geographic location in the country is that particular spectrum used? Probably not 100%. And so how can you maximize taking advantage of that? Now, CBRS is a really great experiment, but it took 10 years from start to finish, right, to get CBRS out the door. How many different versions of 3GPP releases did we go through in 6 years or 10 years? 6, right? So the technology evolved 6 times in 3GPP for commercial mobile broadband in the time it took us to get CBRS done. And so evolving how we actually do spectrum sharing from a commercial mobile broadband perspective is critically important as well. Now, the U.S. government use of commercial mobile broadband is increasing. When JD threw me under the bus earlier, certainly the Department of Defense, right, is massively expanding its expectation of using 5G, and it won't stop when it comes to 6G. I've got friends of mine that talk about, DoD being 0 for G when it comes to its ability to leverage commercial mobile broadband. 5G will be different. And so we're going to see U.S. government use of commercial mobile broadband in a way that we've never really seen before. So there's going to be additional, drive, right, to actually leverage, these capabilities. That is actually going to provide attention on spectrum needs, because what happens if DoD wants to, let's say, use 5G in a spectrum band where it's the federal incumbent user, or where it actually owns the incumbent system, and it can actually figure out a way to use that same spectrum for 5G, it has a desire to figure out how to do spectrum sharing on its own, irrespective of a commercial use case. I will note that, we talked about FCC auction authority. Tomorrow begins the markup of Senator Cantwell's bill that reauthorizes FCC's ability to auction spectrum. Interestingly, in a draft of the bill, which is somewhere north of 100 pages, they are seeking to codify spectrum sharing. Think about that. That's new, right? So we might actually see spectrum sharing codified in the FCC reauthorization for their ability to auction spectrum. Now, the Wi-Fi people like that. CTIA doesn't like that, right? And so we're even seeing tension from trade organizations that are going to influence how Congress reauthorizes the FCC's ability to auction spectrum that will actually drive how spectrum access works from a North American regulatory policy perspective. Another one of those externalities that will have a direct impact on my working group. We've seen a lot of really good projects, though, I would say in the last 5 to 10 years that lend themselves as building a set of tools that we might be able to leverage. DARPA was one of the first ones that really kind of captured my attention. They had this program called the Spectrum Collaboration Challenge. And they did it, so they called it SC2, DARPA SC2, where Mobile World Congress in Los Angeles, before they moved it to Vegas, it was unfortunate. A number of years ago, they took a number of teams, right, that had no knowledge a priori of the environment in which their solution was going to have to operate, and gave them a challenge in spectrum, which is they all were going to use the same spectrum. They all were going to be scored based on how much information they could successfully transmit, and they couldn't score any points unless the other teams scored points too. And so there was an incentive, right, in order to win, to make sure that everybody could contribute to transmitting the data that they needed, and they could use any waveform that they wanted. They could use a commercial waveform, they could make their own. A lot of them used expert engines because they couldn't characterize the RF environment because they didn't know what it was, right? To use something like artificial intelligence with machine learning, there wasn't enough time in the course of the experiment to do that. But it was an early precursor into what should lead to our ability to evolve spectrum sharing well beyond CBRS. So DARPA SC2. Another big project that's going on is in the National Science Foundation, which was discussed earlier. They have a project run by John Chapin called the National Radio Dynamics. And that what the whole point of this project is to try to take different types of spectrum sharing techniques and rapidly mature them to the point where industry actually trusts that spectrum sharing can happen and that it mitigates interference. It's the whole point of that project. And it's a big deal, right? Because if John Chapin is successful with that, it will provide a foundation for which we might actually see DoD and other federal incumbent users trust the solutions that industry develops for spectrum sharing. The National Spectrum Strategy, right, that you guys asked JD about, has spectrum sharing all over it. It also has integrated sensing and communications inside of it. It has a band set aside for sensing, right? If you think about what integrated sensing and communications is, that's spectrum sharing. It's using spectrum for different uses. And so, like, the National Spectrum Strategy is even leaning into the concept of spectrum sharing. And then, just as a personal example, inside of MITRE, right, we have our NIRAD budget, and I won't say how much it is because, like JD said, the companies in the room will laugh at me. But it's a lot of money for my company, and we've devoted a significant portion of our IRAD budget to doing spectrum sharing with ORAN, with the RAN Intelligent Controller, using a near real-time RIC. And so we believe some of the tools that have been talked about today are significant enablers that could radically change, one or more of the different types of spectrum access. And again, coming back to this message that there's no one type of spectrum access in my mind that is necessarily more important than the others for 6G, because we need to figure out how to make them all better and how to use them all at the same time. And so that's where I'm trying to steer my working group. But the tension between the commercial mobile network operators and the hyperscalers who are approaching spectrum access from a very different place because of different business models might make that difficult, if not impossible. So I'll stop there and see what questions.
Thanks, Andy. And I see a question from Ting Tang.
I remember I said you can't ask hard questions.
Good questions, not the hard questions. Really, I think you mentioned is, operators, they are sort of in a bind, but they cannot make more money off the, a lot more data that they deliver, right? So I really feel for the operators. without actually the mobile broadband smartphone, right? Yeah, they cannot charge more for the smartphone.
That's right.
But this thing is making, Google, Meta, Apple, all of them trillion-dollar companies, right? So without actually mobile broadband, without the 5G, right, none of them will be there. So that's the problem, right? I heard Europeans talking about, hey, let's actually charge those hyperscalers, give the money to operators. That's one way to solve the problem, right? So it's drastic, but we need to find a way to help operators in 6G, right? They are actually driving the digital economy. They're driving everything. So, but they're not getting credit for it. And yeah, it's frustrating to see how operators are investing so much, bringing so much to the society, but they're not being rewarded.
And I appreciate the question in that. What I would say is, I think there's an opportunity, right? Obviously, we have the people that are over the top, right? We saw that with LTE, right? I mean, LTE allowed for the creation of all the companies, right, that you would call hyperscalers, right, and enabled them to generate huge amounts of revenue. Google, Amazon, PayPal, Facebook, whatnot. 5G accelerates that, makes it even easier for over-the-top applications to generate a lot of money. But again, I think it's in the evolution of the device ecosystem. And what we might actually see is we might see evolution in the business model of a commercial operator. Maybe what happens, and I cannot remember the name of the company, and I was trying to look for it. Where people there's a person in New York City that has a 5G CBRS-based 5G G-Node B that they've deployed in their home, that they're making somewhere north of $20,000 a month monetizing access to this 5G G-Node B that they've deployed in their house, right? I mean, it's decentralized access to spectrum, right? And so maybe we will see, again, I encourage my working group to think really well outside the box. Decentralized spectrum access might be an interesting evolution. Now, will we get there with 6G and the timelines that Wanshi was talking about? No, unfortunately. But again, it's one of those things that could not only address what Ting Fang was talking about, right? I think it's going to be a collection of things like that that might actually, evolve how we approach 6G. So thank you for the question. And I think question here.
Yeah, I'm very pleased to hear from your very expertise view in terms of spectrum sharing. But I just want to clarify this: whether actual license-based spectrum utilization, it can be shared with some unlicensed spectrum. It's going to be a somewhat very the controversial issues is whether we can have the 6.5 GHz utilization in the future, even in some US and Korea. On the other hand, we also have a very similar experience in the 5.9 GHz for the VTX spectrum. Right. And it's a raw part of 5 MHz. It's allocated to the Wi-Fi. But in the most of copy computation is accomplished in some outdoor side. So it should be some raised some proposal of how to share some such utilization between the licensed operation and the unlicensed operation.
That's right.
You commented that the spectrum sharing is also included such a use between this licensed and unlicensed.
Absolutely, right. The spectrum sharing isn't just about two different types of systems sharing the same band. It can be like we were having a conversation earlier that RAN sharing is a complementary capability to spectrum sharing, because if I'm a user and I have access to two different bands, one is a shared piece of spectrum for commercial mobile network operators, right, under neutral host, and the other is shared spectrum with airborne radar systems. And and suddenly that airborne radar system flies over. Maybe I get shifted over, right, to the commercial spectrum that's shared by all the operators, so that they're not duplicating build-out costs. That's spectrum sharing, right? So not all form. There's not just one type of spectrum sharing. There's sharing between different access mechanisms. There's sharing between different types of, just look for the word sharing. RAN sharing could be an enabler for spectrum sharing, right, between the same band and different incompatible radio systems. So yeah, and I think there can be innovation in a lot of different dimensions.
One thing to be clarified is multiple coordinated right sense the spectrum utilization between this kind of a spectrum sharing can be suitably coordinated by some strong management behavior, such like some CBRS utilization. But in the way it comes to the unlicensed and unlicensed utilization is very, very diverse utilization of unlicensed and radio access technology. So it's going to be somewhat hard to manage and control over the overall use of the shared spectrum is very, very.
That's right. And I guess one of the things I would say is with CBRS, right, they use basically the SAS, right, the spectrum, it's the sensing mechanism. But what that does is that creates performance issues because it puts something in the middle that has to arbitrate the use of spectrum that does it measured in much more than seconds. The second problem that you're talking about, though, I believe Wanchi's going to solve that for us because he's going to figure out how to do AI-enabled radio systems where, that maybe what we end up seeing is we see that the radio system actually dynamically changing how it functions in order to accommodate other incumbent users, right, sharing the same spectrum. It's like maybe even the commercial mobile broadband waveform modifies itself in real time, pulling the human out of the loop, right? I mean, who knows what we can come up with? So we're going to pin all of our hopes on Wanchi. So.
Thank you very much. Thanks, Andy. Really appreciate it. And we can continue the conversation over dinner. This concludes day one. I think it was a really good discussion. And I think it gives us a taste of what we're going to have tomorrow. So thank you all.